Good morning. On behalf of MCCI, I, Anagha Natekar, welcome you all to the seminar and exhibition on polymers and advanced materials in defense. The defense sector in India has seen a significant growth in recent years and is expected to continue growing in the future at a very rapid rate. Polymers and advanced materials have been playing a vital role in the field of defense and aerospace for many years. The material has unique properties like strength, lightweight, durability, and flexibility. We are all here today to know more about the current and emerging trends, as well as the opportunities for industries in this domain. May I now request Mr. Prashant Girbane, Director General MCCIA, to welcome the audience.
Thank you, Anagha. सर्वप्रथम इथे जमलेल्या सर्वांना माझा नमस्कार. Let me welcome each and everyone who's gathered here today. We have here General R.S. Sundaram, Professor Sunil Bhagwat, Professor Radhakrishnan, Shri Abhay Upadhyay, and Mr. Imtiaz Lokhandwala ji. Thank you all for joining us here today. What I'll do is I'll just take a couple of minutes to talk a bit about the chamber, and then we'll leave it to Mr. Upadhyay to set the context. We'll hear Professor Bhagwat, then Professor Radhakrishnan, and of course, we would hear from the chief guest, that's General Sundaram, and then we'll have a vote of thanks by Mr. Lokhandwala. So here we are at the chamber. Some of you are well aware of what the chamber does, but this is my duty to talk to you about what we do and what the chamber is about. We were established 90 years ago in 1934. It's been a good 90 years. And over that period of time, our membership has grown to about 3,000 companies now. There are many large companies that are our member, but more than 2,500 companies that are also MSMEs, small and medium-sized companies. So we shoulder the responsibility to become voice of those small and medium-sized companies as well. As a chamber, we look at about 16, 17 different sectors, almost every slice of the GDP pie, so to say. And one of those important committees is the committee that focuses on defense or national security or defense manufacturing in our case. My colleague Prashant Joglekar, who has interacted with some of you, is the officer in charge there. And we have a committee of our members that come together, and Mr. Fadke there from L&T is the chairperson of the committee. And these members get together and talk about what the agenda should be, what we should focus on, if we have certain representations to the government, and on occasions what the capability building that we need to do for our members. Very recently, we came up with a directory of defense manufacturers in and around Pune region. More than 220 of those, if I'm not wrong, those are the number of members in that directory. So that people are able to understand a lot more about each other and collaborate further. One very important thing in this collaboration has been the interaction with Army Design Bureau in Delhi, as well as the interactions we've been having with the RTN here in the Southern Command, including the interaction with the Army Commander himself. The most important thing that has happened in the recent past is the defense indigenization program, the Atmanirbharta program in the defense manufacturing. Very glad to see that likes of General Shekatkar, likes of Nitin Gokhale, many of those who have come here, talked, General Hasabnis, many of these individuals who have talked from this very forum in the past few years were deeply involved when it was getting shaped up and then communicating to you all about what it means. As part of that, it's been very interesting. Whenever we crossed even the Southern Command headquarters, right, one would be a bit more worried. I'm not using the word scared because that's the so-called army area, or what did you call it, Lashkar. But now, it's very interesting when we have the army commander on the stage and says, here, I would like to share with you the requirements of the army, and you come forward and interact with us so that you are able to engage with us. Now, that's very, very encouraging. And that has made kind of great strides for the defense manufacturers in the country. No wonder when the GDP growth of India is the largest in the entire world among the major economies, what's driving that needs to be seen by looking at sectors that are growing faster than the India GDP growth rate itself. Defense manufacturing is certainly one of those sectors. It's not only helping the defense manufacturers or the people employed there, but also helping us increasing our exports. Today, we are one of the top 20 exporters in defense manufacturing, hoping that we would continue to inch up on that ranking as well. Very recently, we had the Army Chiefs Conclave here next door, and we talked, I got to hear about many perspectives from Army chiefs from various countries, especially African countries, and their keen interest in understanding what our defense sector is doing and how they could also engage with us in terms of procuring what we produce. I think in all of that context, in the last conversation that we're having, we were discussing about, we understood from the RTN, we understood from the Army Design Bureau and others, the importance that we'd have on polymer and advanced materials in defense as well. This was exciting for me especially. I normally don't say this publicly because I fear that people might ask me questions about the topic, but I did chemical engineering. I normally don't talk about this because that's been a long time ago, and Professor Bhagwat taught me. He's here on the stage. Especially when I meet professors from UD now called ICT Mumbai, I certainly do not talk about this. But now that I'm on the stage and the schedule is packed, there may not be opportunity for questioning me, and hence I'm daring to say this. Especially very, very important in India, the kind of strides taken in polymer engineering, whether we have some great names like Dr. Mashulkar here, Professor Ashish Lele here in Pune, and many others that I have personally interacted with. I'm very confident that the good work that's happening in the polymer sciences, in R&D, in manufacturing, would also come forward to contribute in defense manufacturing and in the process, not just in the national security, but also in nation building, because it will contribute to a sector that's growing faster than the GDP and hence supporting the GDP and hence pushing the GDP forwards, pushing the economy forwards. That's the great significance of this sector. I think I should stop there because you would get to hear from many other luminaries who have gathered here on the stage today. Thank you so much once again, and look forward to see you more often at the chamber. Thank you. Over to you, Anagha.
Thank you, sir. Let me now introduce Mr. Abhay Upadhyay, Chairman, Indian Plastics Institute General Counsel. He holds a degree in engineering with specialization in electricals and electronics. He has worked in various roles across India for over 10 years. He started MIFA Systems in 1992, which has completed 30 years. MIFA is a leading system integrator for automation solutions working across India for OEM and end users across industry verticals like pharma, plastics, ferrous and non-ferrous metal, petrochemicals, heat treatment, dairy material handling, etc. I now invite Mr. Upadhyay to set the context.
Thank you very much for a good introduction. Good morning, Pune. Yeah, army है तो जोर से बोल सकते हो. Good morning. Good morning again. Good morning. Thank you. I have been assigned a task of setting the tone for today's seminar, and I hope I will be able to do that. Before I go there, let me thank all of you for giving this opportunity to IPI and work with defense. Thank you all the distinguished members on the dais, Major General Sundaram, Professor Bhagwat, Prashant Girvane, our own Dr. Radhakrishnan, and Chapter Chairman Imtiaz. So it gives me immense pleasure to introduce IPI first, because IPI is a honorary organization which works in the betterment of plastics. We give a lot of knowledge shared seminars, we give a lot of student activities, we take them to industry, so academia industry interactions. We also arrange expert lectures for them, and all such activities are done across India. So I would also like all of you to join IPI with all wholehearted, so that you can also do a lot of such activities in your given time. Plastic as such is a very, very integral part of our life. We just cannot be out of plastic. Yet it has got a lot of bad name because of I would put it into two factors. One is the littering habit of what we have, and second is the bag, the panni, what is called. It's hardly, I would put it hardly 0.1% or less than 0.1% of the total plastic business. But it has a capacity to damage the whole plastic image. I mean, I can imagine a lot of people showing cows eating bags and all that, but that is not the true plastic what we are talking about. Plastic has very special characteristics. In fact, I would be very honest here to put that plastic is the greenest material ever found by human beings. Believe me, because every other alternative needs to be either mined, or woods have to be cut, or jungles have to be vanished. This doesn't happen in plastic because it is a byproduct of a product which you really need. Petroleum you cannot ignore, and petroleum, once you have petroleum, you have plastic. Okay, so there is no drilling, there is no digging, there is no damaging to mountains and jungles. Okay, so if you put plastic in totality, it has wonderful applications, reusability, recyclability, and with the modern event of plastic and a lot of engineering additions to plastic, which was supposed to be one of the softest material ever, has replaced many of the metal applications, steel applications, where the parameters or the strength of the material is much more than even steel in certain cases. So defense should not be an exception, because they need very tough materials, they need very rugged and prune materials. So plastic has evolved as lighter, stronger, and better in many tough applications. Today, automotive, aviation, railways, space, infrastructure, shipping, you name the industry, you name the vertical, and there is nothing that can escape plastic. Okay, it is something like electronic has taken over on the one side, plastic has taken over on the material side. So defense cannot be behind in any way. You name the application in defense also today. Most of the applications are being done by engineering plastics, like bulletproof jackets, severe cold and winter condition thermal wears, special boots, special heat resistance part for automatic guns where magazines get hot, missiles deployment and portable guided launch weapons, helmets, parachutes. Composites are now becoming a very significant part in naval application also, because they have corrosive resistance, and the life of composites are very good. So submarine hulks and even some ship hulks are being made out of composites. Fighter planes also have a lot of applications, and they have made it lighter. I myself have worked with HAL in Bangalore, where we did some thermal furnace application for helicopter in Bangalore, where they used to do the total front glass. It's now polymer, but not glass at all. Numerous other applications which we can go on counting upon. To avoid foot soldiers' fatigue, the weight of the guns have also been brought down, and polymer and composites have a tremendous future. Whatever you say, it is going to be there, and it is there. So let us welcome all the dignitaries who are going to speak after this session, and they are going to enlighten us about the new applications, the new developments, and the strength and the mechanical properties of the whole engineering plastic which is going to come out. Thank you very much, and let's all enjoy this session. Thank you.
Thank you, sir. It is now time to felicitate our guests for today. May I now request Mr. Girbani to felicitate our chief guest, Major General Sundara. I request Mr. Upadhyay to felicitate Dr. Bhagwat. And Mr. Lokhandwala to felicitate Dr. Radhakrishnan. I now introduce Dr. Sunil Bhagwat. Dr. Bhagwat has very recently taken over as the director of IISER Pune. He holds a PhD in chemical technology, and his research is in the areas of interfacial science and engineering, energy and energy engineering, computer process simulation, and artificial neural networks. He has had a distinguished career and has many noteworthy publications and patents to his name. Before joining IISER, Dr. Bhagwat was a professor and dean academic programs at the Institute of Chemical Technology, Mumbai. He has been a popular teacher and has received several awards on this front, including the Indian National Science Academy's Best Teacher Award in 2016. I now invite Dr. Bhagwat for the special address.
Good morning to you all. Thank you for the nice introduction. Major General Sundaram, Dr. Radhakrishnan, IPI Chairman, Mr. Abhay Upadhyay, Prashant Girvani, Director General of the MCCIA, Dr. Imtiaz Lokhandwala, the Chapter Chairman of IPI, other distinguished guests. I would have said ladies and gentlemen, but I see a gender bias here. Good morning to you all. As Prashant was talking about, and Mr. Abhay was also talking about plastics and the negative side of it, it touched the chord. See, the story is like even the petroleum and the pollution that we blame today, more than 100 years ago, it came as a solution to a pollution problem. There was an article in the New York Times 125 years back that the vehicular pollution in New York has grown up so much now that if it grows any beyond that, people will have to leave the city. Now, this is the time I'm talking about when there was no petrol vehicles, no diesel vehicles. And what was this problem that they were talking about? Now, those of you who have visited Matheran would remember the all-pervading smell of horse excreta. And the problem they were writing about of all the horse carts and the horse excreta that will lie everywhere, which doesn't even biodegrade so easily. And imagine if today's number of traffic in New York or even in Pune was to be with horse carts, what will be the situation? So when the electric cars came in the beginning of 20th century, and yes, electric cars is not a new fad, it was there 100 years back, and the petrol and diesel vehicles then replaced it. So the petrol and diesel cars or the electric cars then came as a solution to that pollution problem. However, the usage of that solution today has risen to such a scale that we think of an alternative. So even plastics, when they came, it revolutionized so many things. To give an example from military operations, a man named Carruthers had developed a polymer which he thought would be a very good polymer to make stockings for women who wear a skirt in the Western world, where cold countries. Came Second World War, and there was a realization that use of aircrafts had risen so much, and we all know about the Battle of Normandy and what is the primary role that paratroopers played in that. And at that time, or just before that, the parachute ropes used to be made with cotton. And there would be a certain percentage of the ropes which would break when a paratrooper is dropped. obviously, a paratrooper who has a broken rope simply drops down with no contribution to the battle on hand. And Caruso's development of making that new polymer, nylon, gave an entirely new material to make those parachute ropes, and that transformed the way paratroopers could function. Perhaps the world history would have been different had the Normandy battle turned out differently. So the role of polymers is not just today, it has been for a very, very long time. Even recently, when you talk about polymers like polyaramids, Kevlar, as it is popularly known, and you look at the way things developed in the developed world, everybody talks about the military developments that happened in the United States, military or space, and its contribution to science is tremendous. But it is noteworthy that the developments there did not happen by starting government-owned businesses to manufacture. They have very close tie-ups with the private corporate world, military tie-ups with private corporate world for manufacturing strategic materials, making sure that we are not dependent, they were never dependent on imported materials. And that is the route I'm sure the country will take now. We have several such polymers which have been developed. Prakash Bhai is going to talk about polyetheramides, polybenzimidazoles that Ghada Chemicals has, or there are many other such developments. NCL's Ultem is one such product. But do we see full implementation on large-scale manufacture and usage? The answer is probably not to its potential. And it is not about technically it being not superior. When you manufacture something at 5 tons per day or 5 tons per annum, vis-a-vis 1,000 tons per annum plant somewhere else in the world, the economy is different. The economy of scale doesn't permit it being sold at the same price as we would get imported materials. And if we look only at the cost and not at the strategic importance of the material, we would never have Indian industry supplying materials. There are several of these polymers which are made world over at 5,000 TPA. Indian military may be about 500 TPA. We are perhaps less than 10% of the world's military consumption, which means even if the entire military orders were coming to one company, the size of that company will be smaller, significantly smaller than the competing world industries. So my understanding, and mind you, I am not from the field of polymers, my understanding is that our industry can definitely make a lot of products for defense applications. But perhaps what they need is some kind of a tie-up and some kind of an assurance of the market, of course with specifications and guarantees to be met. But if there is an assured market, typically the chemical industry, sir, has a payback period not less than 3 or 4 years, which means unless there is a guaranteed market for 3 or 4 years, no company will venture into manufacturing at a scale which can be supplied. So perhaps if the defense services, defense organizations partner up with these private industries, where they can assure them the market for the next few years, they would venture into putting that capital, and the time is not too far that India would be completely self-sufficient in many of these polymers. So my firm confidence that my previous organization, the Institute of Chemical Technology, or the current organization, ISER Pune, are fully capable, along with NCL, fully capable of developing things. Our industry is fully capable of manufacturing them, and perhaps the third help which they need is marketing assurance. If that comes through, I think it will be the story like ISRO is substantially now dependent on Indian manufactured materials. So if similar thing can happen with private sector in defense polymers, I think seminars like this would be a very good contribution towards that. So with this, I'll stop here, and very good morning to you all once again, and wish this seminar a great success. Thank you.
We have with us Dr. Radhakrishnan for the keynote address. Let me take a few minutes to introduce him. Dr. Radhakrishnan holds a Master of Science in Physical Sciences from IIT Kanpur and a PhD in Polymer Science and Materials Science from University of Pune. He has more than 35 years of experience as senior scientist in R&D laboratories of CSIR. He was the head of the Polymer Physics Laboratory at NCL. He joined as a professor and director research, development, and innovation at MIT Pune in 2012. His main responsibilities are to promote and lead R&D activities, guide PG and PhD projects, interact with other institutes for collaborative research materials development for special applications, and many more. He has published more than 155 technical papers and has won many national and international honors and awards for his outstanding scientific achievements. He holds 38 patents in India, 6 in the USA, and 3 in Europe. His current areas of interest include specialty polymers and blends, advanced materials and applications, nanomaterials and composites, water treatment, green polymers, advanced coatings, fibers, and textile treatment. I invite on stage Dr. Radhakrishnan.
No, it's okay, it's okay. Because I have to see on the screen, no, so that's why I was looking at. Okay. Good morning, everyone. So I hope the tone has been set for this seminar, which is polymers in defense, polymers and advanced materials in defense technology. Okay. Now, I was also a part of IPI, Indian Plastic Institute, Pune chapter for quite some time. And we have held this type of seminar, even MCCI itself, somewhere way back in 2008 or something like that. Okay. So that time MCCI's defense group and polymer group joined together and I was part of it. Now that was about almost 10, how many years back? 15 years, 12 years back? Okay. Now we are having the same thing here again and we are going to talk about it in a different way. That time it was upcoming and the polymer also was upcoming and people were looking for many applications and defense area seemed to be quite good because they have a lot of money and they could, I think, buy at whatever cost because of strategic importance. So people were interested. But as I see it from my perspective, that the thing has not taken place so much as Modi ji has been saying, make in India, and he is pouring in money to defense and other organizations. But if you look at it actually, as Professor Bhagwat said, that we have the technology, we have people, we have everyone, but we have not moved forward to make it happen. But anyway, just to create an interest in what are the aspects which we look for as of now, in the past as well as in future. So what I would like to see is sort of give you a small review of what are the requirements of defense and why polymers and why advanced materials. Now everybody is talking about polymers. Everywhere there are plenty of polymers. Why? Because the requirement is such that you have various requirements coming from different areas, okay? Coming for example, energy, transport, environment, you have health, you have food, and you have electronics. I have not mentioned defense over here, but there, all these sectors, each and every part requires polymers. And it has been made in polymers, and so the growth of polymers has grown so tremendous that world over you cannot, get away from polymers. It is there in every field. And when you start from here, in fact, when I was talking about the need of the polymers and for the daily life, and we are talking about polymers and environment, the pollution is not because of the polymer itself, but the user. The user creates the pollution, but polymer by itself is non-polluting. And it, in fact, one of the cleanest material which you can think of. Now, apart from the age-old polymers like, what we call commodity polymers, when you look at the applications, various applications which are specialty, like for example, defense and electronics, you require special materials to be developed. Now, we have done that. For example, what are the requirements of polymers for defense? Now, if you look for polymers for defense, what are the requirements? Is that it has to be ultra strong, lightweight, high velocity impact resistant, low velocity impact resistant, non-corrosive, easy to fabricate and assemble, and materials for special applications. Now, these materials are also polymeric based or multi-component based. So, but they are so specific for that particular application that no other material will be replacing that. Now, when you have modern warfare, today the modern warfare is entirely different. What you can think of is that it's like almost like a video game. Sometimes you feel that the fellow is pressing button and there he goes, and the missile goes and strikes the target. And it is just, going so much away from the normal human being and human interaction that the modern warfare is more like a electronics warfare and more with the gadget warfare. And so what you require is smart materials, sensors, actuators, self-healing, shape memory, and wearable electronics, where you can wear the electronics. It's so flexible, anywhere you can take the devices with you and carry it. So you have all kinds of things which are coming up as far as the material requirement is concerned, even from defense perspective. Now, somebody mentioned Kevlar. Kevlar, in fact, is one of the earliest one, which is actually polyphenylene terephthalamide, which is actually replacing nylon. Nylon also was mentioned. But if you see the strength-wise, the strength of nylon is something like 132 MPa and modulus is 5 to 6 GPa, whereas when you are talking about tensile strength of Kevlar, it is 229-30 MPa, and the modulus is 70 to 100 GPa. So unthinkable. A polymer which is supposed to be flexible, easily breakable, easily cut and things like that, and you have such a huge strength in the same polymer, which is just because of the chemistry behind it. Now, if you see this particular aspect, it was one of the earliest to be used for anti-ballistic. And in fact, you have police and everyone is wearing this Kevlar jackets, which bullet doesn't penetrate Kevlar, okay? And one of the things is that bullet, when it is high velocity, this is high velocity impact resistance. So you have bullet penetrating and it just goes, doesn't touch the body. It is getting absorbed within Kevlar. Now, Kevlar is one part, but that is a very niche product made by a single company. And it is owned by a single company. And now, if you wanted to make it available to everyone, then he will control, that company will control the world. So we have some alternatives. And fortunately, we have alternatives from common high-density polyethylene. Now, this is not common high-density polyethylene, it is polyethylene, but ultra-high molecular weight polyethylene. the molecular weight of this polyethylene is 10 raised to 6 plus, okay, millions of times. So what happens is you have now a polymer with such a high molecular weight, but that also gives it strength. Now when you say this particular polyethylene, I will compare it with other later, you have an ultra high molecular weight. Because of that, it is very difficult to process. It is normally not used, only it is used in bearings by that too special processing techniques. Because the molecular weight is so high, you cannot use it in normal extruder and you cannot use it in solution also. So you have to have special technique to make this into different forms or shapes. But now you will see that molecular weight has given it such high strength. You have tensile strength of what? 4.1 GPa, okay? And modulus 95 to 150 GPa. Okay, imagine a polyethylene, which was ordinary polyethylene going around all over the place now. They are blaming it also, but we have such high strength coming out of the same molecule, just because you have increased the molecular weight. And of course there are some other requirements for that molecule, but then you do have such high strengths. Now this is a Dyneema technology. I don't know how many of you have heard of that. It is a Dyneema who are the first one to make fibers out of this, and these are also anti-ballistic. Okay, they are competing your Kevlar. So you have ultra high molecular weight polyethylene, which is UHMW, which is converted into a fiber, which is called a Dyneema fiber. Now you have bullet resistant vests, and you have inserts, helmets, anti-ballistic protection, and so on. So there are many, many applications for this, and it is 40% stronger than aramid fiber. So you have a polyethylene which is getting into a high niche area. Now why do we want to replace all this? Now if you look at this particular vest, anti-ballistic or protective layer, starting from metal, it has a density of 6 to 7 or even higher. Okay, Kevlar density is 1.4 and Dyneema density is 0.96. So it's such lightweight material with such high strength, which you can imagine it has just converted everything topsy-turvy, and you have such, anyone can wear it now. You see even TV fellows are wearing this Dyneema vest going to the war front. Okay, and you have all kinds of protective. It has also incorporated into helmets, and we have armor plates made out of Kevlar and Dyneema. Okay, now you will say that armor plates out of plastic. Well, why not? You have such strength, you can have it. Now you see the ballistic performance of these, and this is handgun. Okay, it protects you from that. Some of it protects you from even AK-47. Okay, so you can imagine what is the protection level you can get out of these polymers. These are just polymers, okay, plastic, but then they are protecting you. Just like PPE protected you against coronavirus, these will protect you against all the bullets. There's one thing very interesting which I would like to point out here, is that these polymers have been used in not only your actual warfare with the soldiers, but they are also used for protecting common civilians against all this warfare and fragments coming out of all this. For example, this just like a blanket, it is like a blanket, it's called a bomb blanket, and you can sit under it and there will be nothing happening to you even if a bomb busts next to your next building maybe. So in fact, why this was not used in modern Ukraine war, I don't know, but I think maybe it is too expensive or what, but this is a simple blanket made out of Kevlar, multi-layer, and it protects you against all the fragments and all the things which are coming out of the warfare. Now let's talk about ultra strong materials. So we are talking about ultra strong. Now when you talk about carbon reinforced plastic, it's one of the best material combination which gives you tremendous strength for the composite material, and depending upon the polymer matrix you get such high level of strength which is comparable to steel, and in fact it is lighter than steel. The strength is there, but the weight is not there. So you have such great advantage. For example, if you have a reference like aluminum, specific strength is 115, titanium has 76, whereas carbon reinforced plastic has 785. And now you can imagine 10 times more than that specific strength. Why? Because it has strength, but there is no weight. So you have such wonderful material here which can be used in a number of places in defense, or when you talk about Army, Navy and Air Force, it can be used anywhere. Now this is the naval applications of carbon reinforced plastic. Just giving you some pictures. Different parts of naval ship is being made with carbon reinforced plastics. Then you have submarines being made out of carbon reinforced plastics. And there are very specific, something like turbine blades, which are again reinforced with carbon fiber, and a very particular shape, which is very difficult to make with metal. It's practically impossible to weld all this together, but can be made out of plastic. That is one advantage of plastic, that it can be molded in different forms and very complex forms. Okay. Now there is another thing which I would like to point out is wood polymer composites. Wood polymer composites is taking off quite a lot because you save a lot of wood, and this has got tremendous applications in Navy, and I think naval area, I don't know, I was in NRB panel and somebody from Navy is here, he can take it up somewhere along with this particular application. If you talk about applications in aircraft, you will see that so many of parts are being made with carbon reinforced plastic. Now let's talk about the local. We have Tejas, Mark, I don't know, anyone from Air Force here? HAL is there? Somebody is there? Yeah, okay. So you have Tejas, which is having increasing use of carbon reinforced plastic because you want lightweight, you want speed, and you want to maintain. So the increasing composite material will save energy. Not only that, you will see that they are going towards 45% of airframe into carbon reinforced plastic, and that is almost 90% surface area, and this is highest among the contemporary aircrafts. So you should be proud that we are doing something which is almost up to, let's say, world level. We are not lagging behind in that particular area. And this particular launching of Tejas has taken place, or is going to take place also. One of the other added advantage is that carbon reinforced plastic doesn't have fatigue, which normally metals have fatigue and cracks. Okay, so that's an advantage which in fact mechanical and chemical engineers can think of. Now modern, I said warfare, you cannot avoid it without drones. Drones, you see drones everywhere. Now what are drones made of? They are all made out of plastic and carbon reinforced plastic. Okay, and such complicated parts cannot be made out of metal with welding and cutting and all these things. They are molded out of plastic. So if you see this drone, this is quadro, that is 4 propeller. So many parts are there which are made out of plastic, injection molded or hand layup or any other technique, and it's a very complex design and complex things. You can visit some of these, our exhibitions, some of them are doing this type of complex molding, and they are doing really precision molding also and complex shapes. and you can see what can be done out of plastic. So this is a typical, say, blade of the drone which has been injection molded and which is there used by drones. Drones parts are extremely important, and I think we have a big, huge market if you can make drone in India. Now I'll come to one specialized absolutely area, which is actually electroactive polymers or conducting polymers, which is in fact, close to my heart. I have been working on this since 1985, and it's amazing material. Plastics, you always think in terms of insulating, everything insulating. But here you have a plastic which is conducting, which is semiconducting, and which is competing with silicon, which is competing with many other semiconductors. Okay. Now, advantage that you can make it easily and make it on large area, mold it if you want, you can do whatever you want. So in fact, you have different areas in which it has found, just like I showed you, the demand is there and the polymer is there. So we have synthesis modification of pi conjugated extended polymer, which is actually a conducting polymer. It has a specific structure, chemical structure. So you have a pi conjugation, and it can be used for sensor actuators, it can be used for waveguides, photosensitive materials, it can be used in FET, diode. Now you are talking about quantum electronics, it will go there also. Okay? So you have a tremendous number of applications for conducting polymers. Now, why in defense? What is so special? Now there is a defense area which, because of modern warfare, as I said, it may contain chemical, it may contain biological, it may contain whatever vapors. You require sensors and actuators for remote areas and detecting well in advance what is happening. Plus, you have other bulk applications, like for example, EMI RF shielding, which is very important for defense. I will come to that. And you have anti-static, which is needed for all the high explosive area. You have other applications like batteries and fuels, which require conducting polymers. Now, other special applications, like for example, electrochromic display and all these things. But those are highly advanced things. Now coming to EMI RF shielding, if you look at the radar absorbing materials which are made out of conducting polymers and conducting polymer hybrid composites, you will see the aeroplane has what is known as radar air cross section, radar cross section. So can you detect it with a radar? It doesn't depend only on the size of the plane. It depends upon what it contains. And that is more important than the size of the plane. Because as you see, as you go down, you will see that the planes are becoming, MiG is very highly detectable, okay, by radar, because the radar cross section is sufficient. But as you go down towards stealth missile, stealth aircrafts like B-22, F-16 and so on, the cross section is so small that you cannot detect it on radar. Now, why is that? Because it is having radar absorbing material. So radar doesn't detect it at all. It is just through, that it doesn't see it. So this is a very, very important area which is for the defense application. Now there are other applications also for conducting polymers, and I will come to that little later because I think I have already covered some of it. What is more important is sensor, actuator, and there is a very interesting aspect of conducting polymers and which will be very useful for aircrafts, and that is polymeric piezo sensors. So we have a polymeric piezo sensors which is sensitive to pressure or deformations. These can be incorporated inside a plane to monitor its health. So health monitoring of aeroplane, health monitoring of submarines, health monitoring of all these can be done with these devices. Like it's so sensitive that it can be used in vibration monitoring as well as any defects. Okay. Another aspect of conducting polymers is that it can change color. It can be thermochromic, electrochromic, solatochromic. It changes color depending upon what you expose it to. If you expose it to heat, it changes color. If you do apply potential, it changes color. And if you put chemical vapors, it changes color. So you can use this for sensing all kinds of chemicals, all kinds of heat and other things. And it can be used as a camouflage. I have mentioned that, and I will mention that in detail in my next talk. Now, one of the things is polypyrrole deposited on fabrics can be used for health monitoring of persons. And this can be, as I said, it can be worn by you. And nowadays you are getting some watches and other things which monitor your health. It is because of these conducting polymers which are going into that. One more very important application is that it is corrosion protection health by conducting polymers. Now, specifically for Navy, you require tremendous corrosion protection, especially in marine environment. And we have developed rather, epoxy polyaniline coating which can withstand high exposure to salt, spray and salt environment. And even after it is scratched, it doesn't corrode. So it is so it doesn't corrode. So you will see that this is a fantastic material. And I will just like to mention that a person who did PhD with me on this polyaniline is having a stall here, and this is the first time we are manufacturing this. Okay. Now there are other things like active fiber composites, which also can be used for health monitoring of various devices, persons, and so on. So here what happens is you have a conducting polymer combined with piezo material, and it is a hybrid. Since we are talking about advanced materials in this seminar, I thought I would mention this, that this is another area where one can think of making something which is useful for defense. One thing I would like to mention in the last and final comment, basically, is that yes, this is all very interesting, this is all true, we can make it, but then come to a point. Can we make Kevlar or Dyneema in India? Question. I am asking you, everyone, and you can reply to yourself or later on give me the answer, but then we know that it is very difficult to make this, but it is not impossible. But then what we require is all the wherewithals for making them. Can we process carbon fiber reinforced composites on large scale in private industry? I don't know how many of us can really do that, because carbon fiber itself is not very easily available, and we can make it, but then those trials were not very successful making carbon fiber itself. But we have carbon fiber reinforced materials which can you process is the question which I am asking. In your machine, can you put it in your extruder or put it in your let's say extrusion plant and make sheets out of it, or can we make something out of it? Is the question this I am asking to the plastic manufacturers as well as other people. Okay. Can we repair this? Okay, you can't make it, but can we repair carbon reinforced plastics? Suppose you have an aircraft which is having this, and then it has a small defect. Can we repair it? Are we having that technology with us? Is the question which I am asking. Okay, I told you that we started all this some years back, but now today, do we have the answers? Is the question. Do we have radar absorbing material? Radar absorbing, fantastic. Just now you saw. But do we have that material? Is anyone making it? Or is having a coating which can be used by HAL or by anybody? So do we need to have those type of industries who will say that yes, we can make it, and here, give me a customer and I will sell it. But then that depends upon how defense ministry, administration, and everyone takes it up. Because they need customers, guaranteed customers, to make these specialty materials. Okay. Are the education institutes imparting training in this? Are they up to mark? Even IITs or ICER, I will say, are they up to mark to make these? I don't know. Do they have it in their course? I don't know. So we have to ask these questions. So if we want to make this, is Defense Ministry and DRDO administration ready for collaboration? Collaboration with public, collaboration with common industry, collaboration with upcoming industry, startups, everyone? Are they ready? Will they say that, okay, I will take your material, take your component, take everything, and I will incorporate it in my, let's say, military application or naval application or aircraft? But are they open to it, is the question which I am asking. Now, hope we move ahead. I said that we carried out this earlier, but now I am hoping for the best that we can move ahead for making India. Thank you.
Dr. Radhakrishnan, I think I need to add something here. If there is a will in the government, we could make Buddha smile in 1974 with full might of PMO, DRDO and Bhabha Atomic Center. We made the atomic bomb in Pokhran. So will has to be there, and that will is there in this government. Probably this is possible. Thank you.
Thank you, sir. I now take the pleasure to introduce our chief guest for today, Major General R.S. Sundaram. Major General Sundaram, Sena Medal, Vishishta Seva Medal, is an alumnus of Bhartiyar University, Coimbatore. He has done his bachelor's and master's degree in mechanical engineering and also completed master's in management studies and in public administration. Major General Sundaram is a specialist in armored fighting vehicles and has a vast experience in their maintenance as well. He has also been the chief system engineer, armament, and was closely associated with the engineering sustenance planning of various armament systems inducted in the Indian Army. He has also served as an advisor to the Botswana Army to the Chief of Mechanical Engineers. Major General Sundaram has got Sena Medal for gallantry operation while serving in sugar sector and Vishishta Seva Medal while commanding an armored division EME battalion. He is now tenating the appointment of Major General Electronics and Mechanical Engineers in Headquarters Southern Command, where he is responsible for engineering support and maintenance of all kinds of equipment deployed in Southern Command area of responsibility. I now invite Major General Sundaram to address the audience.
Mr. Prashant Girbani, Mr. Abhay Pade, Dr. Sunil Bhagwat, Dr. Radhakrishnan, Mr. Imtiaz Lokhandwale, my brother officers, ladies and gentlemen. First, I would like to thank each one of you for inviting me as a chief guest for this function. It's a learning for me also. The way, sir, you presented. In fact, I stand more educated and I understand the concerns. I had prepared a speech on the military applications of polymers and advanced materials, which I shall not cover now, because, sir, you've covered most of it. But what can we do for you? We in Southern Command, how can we facilitate you, or what we can do for you? So you'll have to forgive me because you would have heard it quite often. But for those who are present here, let me explain to you what we can do. Southern Command starts right from Sagar in Madhya Pradesh, and we go down till Trivandrum. Gujarat, Maharashtra, Andhra Pradesh, Telangana, Tamil Nadu, all this is in our area of operations. What do we have here? We have all kinds of units out here. The infantry, the artillery, the mechanized infantry, the armored divisions, air defense, you name anything in which polymers, all these advanced materials are used, all these units are here. We've got various training institutions. We've got our engineering colleges. We've got the College of Military Engineering in Pune here. We've got the Military College of Electronics and Mechanical Engineering in Secunderabad. We've got our Military College of Telecommunication and Engineering in Mau, and various such institutions. We've got our training institutes, and we've got also our training centers. Why am I telling you all this? I'm just telling you all this because today, we in Southern Command, under the leadership of our Army Commander, General A.K. Singh, we are open to you. Our doors are open. Our training institutions are open. Our units are open. You want to come and interact with any of our units, you want to interact with any of our Jawans, you want to interact with any of our specialized training centers, our colleges, the doors are open. We've also established something called S2A2I2, that's the Southern Star Army Academia Industry Interface. We've got the regional technology nodes which are functional in Pune. All you have to do is contact any one of this S2A2I2 or the RTN and tell them what is your problem. Tell them what is your requirement. In case you want to understand what is the requirement which these forces as such have. If you want to understand what is the kind of things they're looking forward from you. You all are welcome. We'll facilitate it. We'll let you all interact with our troops. We'll let you all understand what is our requirements. We'll understand what is your concerns. We'll all try and work together and see how we can take it forward. I want to assure each one of you that we are here for all of you all. Then we've got various problem statements which have been defined. They are on the websites. We've got a DOI, we've got an Army Design Bureau. There's a whole lot of institutionalized mechanism. And so like what was your query in the last thing, be rest assured, today everyone is looking forward for indigenous solutions. Under the leadership of a PM, where he's looking at self-sustenance, and the various wars which have been fought, which has taught us that there's no way you can be dependent on some other country if you want to prosper. We are looking for indigenous solutions. We are ready to experiment. There's huge amount of money available. There's huge amount of indigenous grants available. Research and development grants available. All you have to, there is an excellent forum where you all have to just get in touch with us. We can collaborate, we can work together, and we can address a lot of concerns which you have. And we want all of us, and all of these new technologies, new materials, lightweight. Today the Arjun tank is weighing around 60, 65 tanks. We're looking at how we can reduce it less. We're looking at 40, 45, 50 tanks, 50 tons. So we're looking at various options, various things. And for there's a huge opportunity for this industry. So all I will not take much of time, but I think I've made my offer very clear that we are open to you. Any kind of assistance, anything which you all require, any point of time, please do come over, please do let us know, we'll facilitate. We've got our RTNs here, the regional technology nodes, the numbers are all available. I'll request Mr. Dilwani, you can please flash it here or tell everyone what the numbers are. Please contact us, there's a dedicated cell out here. We'll facilitate what is required. And at the end, I would like to thank each one of you for inviting me. I'll not take much of time. And wish you all the best. And it's a great initiative, and I hope you all achieve your desired results. Thank you.
Thank you, sir. At the hands of the chief guest today, we would now release the seminar booklet. Thank you. I now request Mr. Imtiaz Lokhandwala, Chairman, IPI Pune, to give the vote of thanks.
Thank you, Anaga Madam. A very good morning to you all. Respected dignitaries on the dais, the delegates, ladies and gentlemen. This has been a good start. Impressive speeches by all. First of all, I would really like to thank Mr. Prashant Girbane, who's the Director General of MCCIA. He has given a good overview of MCCIA, who has been doing a lot of things and would like to work further for the industry of Pune, preferably Pune, I'm partial, Maharashtra and India. We would also like to thank, of setting the context, Mr. Abhay Upadhyay, IPI chairman, the GC chairman. He also gave a wonderful thing, what IPI is and what IPI has been doing. And this handshake of MCCIA and IPI can be a good organization serving the industry, the vendors, and the users. This is going to be an amalgamation of two big institutions serving the industry for the country, and it will take India to progressive heights. We would also like to thank Dr. Sunil Bhagwat. The way you put it up with examples, that was excellent. We never thought about it. Solution, pollution, again solution. That was a wonderful thing, sir. Thank you very much for your interesting speech. Dr. Radhakrishnan. Now, what's to be said? I think even if I stand here for the full day, I'll be appreciating Dr. Radhakrishnan. Dr. Radhakrishnan, thank you very much. He is an encyclopedia and wealth of knowledge. Polymers, I think, is flowing in him. Thank you very much for the wonderful session you gave us, the application and the complete usage. That was really wonderful, Dr. Radhakrishnan. And I think we have to take advantage of this gentleman. He has got the knowledge. Now this knowledge has to be converted and be taken up by the industry, taken up by the defense. He's a wealth of knowledge. So the application is for the industry to develop and for the defense to use. This also can be a good amalgamation. Finally, I would like to thank our chief guest, Major General Sundaram. So your words were really welcoming and understanding. The army is there to welcome you. Come, industry, come, let us do it together. And as our Prime Minister also mentioned, we have to go for Atmanirbhar Bharat. And this is the occasion where we can realize the dream of India, the great nation. Thank you very much, Major General Sundaram, our chief guest. His words were really good. And yes, Army is flexible. We as an industry have to accept it and take it ahead. Thank you all. I would also like to thank all the delegates present for giving your time, and thank you for your presence. Thank you to all the stall exhibitors who have taken the effort to come over here and showcase their products to all. It has been really good. My last thanks to all our sponsors. They have so generously come ahead, and without even blinking, they said, yes, let us do it together. And with their support, MCCI and IPI has come together to give you this seminar. And finally, we thank again all the delegates present over here, giving your time, and hope the two technical sessions are received well by all. There is a good share of knowledge, and everything goes well. Thank you very much once again.
We now take a short 10-minute break for tea and assemble back here at 11:30 for the first technical session. Thank you.
तेवढं वाजणारच आहे कुठं.
चेक चेक हॅलो चेक चेक ठीक आहे.
I request the audience to kindly settle down. We will begin with the next session in the next 5 minutes, please.
Requesting Mr. Jayakannan to come towards the stage, please, from ICER.
Welcome back. We now start with our first technical session on polymers use, expectations, and opportunities in defense. I would like to invite on stage Mr. Hitendra Saudankar, Chief Manager, Hindustan Aeronautics Limited, Mr. M.M. Biswal, Business Head, Engineering Plastics, KLJ Polymers, Dr. Kare, Director General, CMET, Mr. Himanshu Dhol, Senior Manager R&D, Atul Limited. And Dr. Samir Joshi, who will chair the session. Before I hand over the session to Dr. Joshi, let me introduce him to all of you. Dr. Samir Joshi holds a degree in polymer engineering along with holding a PhD on waste management. He holds expertise in circular economy, recycling, EPR and plastics, and has his own plastic injection molding unit in Pune. He's a fellow of Indian Plastics Institute and of Indian Institute of Valuers, member Institution of Engineers India, and senior member Society of Plastic Engineers USA. He's vice chairman, governing council of Indian Plastics Institute. He is a member of the World Economic Forum Regional Committee, Plastic Waste, South Asia, and a member on Niti Aayog Committee. He is also working for plastic waste management projects for the Defense Forces. He has several publications to his name and is a regular speaker at national and international conferences. I now hand over the session to Dr. Joshi.
Thank you. Thank you, madam, for the kind introduction. With that kind of introduction, I don't know if my wife will allow me home today. It is a great pleasure to be here and be a part of the first session today, the polymer use expectations, opportunities in defense. We have distinguished guests who are the speakers here, Mr. Hitendra Saudankar. I will introduce them briefly and then we straight away go to the session. Mr. Saudankar has a total industrial experience of 17 years. He's at present Chief Manager in Hindustan Aeronautics Limited in the non-metallic and the consumable materials group. He has indigenously developed many types of non-metallic materials and consumables directly used in military aircrafts. It includes rubbers, adhesives, fabrics, and he has been in the forefront of indigenization of various components. He has 3 patents in the development and applied stage. Mr. Biswal, he is the business head of engineering plastics at KLJ Polymers, alumni of CPET Chennai, has a huge experience of over 37 years, and he joined KLJ long ago, where he is now the business head since 2014 for the engineering compound business. He has been developing strategic partnership and distribution network and has been quite active in this field. Dr. Bharat Bhushan Karagi, Director General of CMET. CMET is a scientific society under the Ministry of Communications and Information Technology, New Delhi. Mr. Kale is currently the Director General, and I said Mr., but he's after a doctor. He did his PhD from CSIR NCL. When was that, sir? When was that? 92. He has over 33 years experience of research. He holds 26 patents and has 27 research projects completed under his leadership. He has published many papers in various scientific journals. Mr. Himanshu Dhol, Senior Manager R&D, Atul Limited, the Polymeric Performance Division. I like to say the polymeric. He graduated from LD Engineering College in Ahmedabad, Gujarat. He has 20 plus years of rich experience in formulating thermoset materials for composite applications. His current activities at Atul are focused on designing epoxy for aerospace, defense, wind, and the automotive industry. He has an ability to build strong relationships with key stakeholders and deliver the project. Mr. Ashok Kumar, Deputy Controller, CQAV Ahmednagar. Mr. Ashok Kumar has a B.Tech in rubber technology and an M.Tech in polymer technology, as well as a very legal angle to it, LLB and LLM. Prior to joining the government service, he worked for 12 years in the private sector. So he brings a rich experience of the private as well as the public and the government side. He has received scholarship from the World Intellectual Property, WIPO, to attend IPI classes, and also various scholarships from Korea, South Africa, and Ukraine. He currently holds a position as the Deputy Controller of CQAV, DGQA, Ministry of Defense, Ahmednagar. So I would not like to, make any more further comments of this. We very well know the importance of polymer use, but we are here to discuss the expectations from the defense sector and the solutions that are there on the table. So may I request our first speaker, Mr. Hitendra Saudagar, Chief Manager, Hindustan Aeronautics, to please take the stage.
Thank you, sir. Thank you, sir, for the introduction. So, my topic for today is indigenous development of polymeric materials for defense and aerospace. As you all know, in the morning we have discussed about the aerospace applications. We are directly working for the fighter aircrafts. So, MiGs were the earlier aircraft, now it's coming the Su-30 aircraft, which has been manufactured in Nasik division. So we are going to cover some of the things like introduction, challenges, future trends, scope, and main important is the vendor development done some of the case studies. So as you know, HL, Hindustan Aeronautics Limited, which is having more than 75 years of existence and manufacturing, overhauling of all kind of aircraft, fighter aircraft, some of the transport aircraft. This is all the services for the Air Force. And we are having the Bangalore unit, which is manufacturing the helicopter for the fighter helicopters, then some of the civil helicopters. Some transports are aircraft manufactured in the Kanpur division, and Nasik is manufacturing the Russian technology-based Sukhoi 30 aircrafts. So you see, there are many type of non-metallic materials. We called it as consumable materials, non-metallic materials. So these are including the rubbers, they are sealing compounds, plastics, fabrics, rubberized fabrics, adhesives, fuel, foam, glass, all kind of non-metallic materials are used in the fighter aircrafts. So you see, so fighter aircraft, what is the basic requirement of the fighter aircraft? Like it operates in all weathering condition. It is cold to high temperature from the Srinagar or Ladakh to the Jodhpur at high temperature more than 45 plus. And like it is working in all raining condition, day and night, low altitude to the high altitude with various ozone concentrations and various rotables, means there are many rotable parts, mechanical parts, operates in all oil, air, fuel lubricants. So basically when we fly the aircrafts, so it is ideally, it should have the zero downtime, it should have the zero maintenance as well as minimum overhauling time. But practically it doesn't happen. So many times we face these issues. So we wanted to at least minimize these issues. So when we develop the materials, so during the development, what is the basic factors we consider? Like structural efficiency, quality, fatigue strength, corrosion resistance, cost of the material, fabrication, service conditions, and various types of loading and environmental conditions. That has taken into consideration. However, in these consumable non-metallic materials, you see there are many materials which are perishable in nature. Like you can see a rubber compounds. Rubber compounds having hardly life from the 3 months to the 6 months. Adhesives, it is having the life from 6 months to the 12 months. So the materials which we are importing for this manufacturing, most of them are, we are really from the past, Russia is main our strategic partner for the defense. So imports where comes from them. Then we have started the development of these activities in-house as well as with the business partners like many eminent companies, and we are taking them as a business partners. So we have started the same thing. Instead of importing that things, we'll develop the same thing in India with our Indian peoples, with our Indian technology. So I'll just brief some of the procedure when we go for the indigenous development of any materials. You see, we take the requirement, what is the basic requirement for our further production, for the manufacturing. Then we do the feasibility study. Then we go for the specific requirement, specific finalization of the specification, test schedules. Then we go for the market survey. Who are the companies involved in manufacturing of these kind of materials? Then we go for the further release of the purchase order for that company after all commercial procedures. Then we go for the prototype. Company goes for the product manufacturing. They supply us as well as they test it at their end. Then after all these testings and validation, everything that has been witnessed and offered to the government agencies like DRDO, DJQA, and based on the satisfactory results and the performance, it has been clarified or it has been approved for the aircraft airworthiness application. So this is general the procedure which we followed. Then you can see initial there is a specification, then there is after testing, then part manufacturing, that part goes for the induced testing, actual testing, number of functional tests, cyclic test, and then after everything is then approval has been granted for that particular material to the particular company for specific period. Then you see, whenever we go for this thing, we know what are the challenges our vendor faced, what are the business partners they faced. So I just wanted to cover that thing because these are the questions which many vendors, many manufacturing agencies comes. So there is you can see low volume and numbers required. As you know, military aerospace sector is not the very bulk manufacturing we are doing. We are doing in a less quantity because it has a limitation. Many times it is a licensed production manufacturing, so it has a limitation as well as materials shortages issues. So volume is less, numbers are less compared to you can see automobile or other industries. So how can we tackle that things? So we identify the requirements in the early stage of the life cycle of the aircraft. You can see a life cycle of the aircraft is around 40 years. When it starts, suppose Sukhoi 30 project has come in 2002, 2004, this thing. So it has a total life cycle of more than around 40 years of life cycle. In that, after 10 years, it has a overhauling of that aircraft and 4 times it gets overhauled. So in the defense requirement, we can club together that larger orders rather than the small quantity in multiple orders. Then contractual positioning, high cost to be factored into the pricing of the products. So even if it is a less number, we ask the vendor, at least you can come forward for the development of this thing with that particular quality. Cost is another factor which can be considered later on. Then the non-availability of design data. Many times when we go for the development, the OEM doesn't give the technical support for us or technical details in that materials. He just tells us, take it this material, that's it. This is your requirement 10 kg, 15 kg, 100 kg, 1 ton, that's it. You take the material, forget it. So when we go for the development, we face the technical challenges. So how we can go for that? So we can jointly involve the technical requirements by such elements, like some reverse engineering we can go for that, then contractual position to obtain such data. So we can go for, by this way, we can, this non-availability of this technical requirement, we can go for that. Then stringent quality requirements. Yes, quality is a bit required, important, because aircraft flies, our pilot is there, the life of pilot is very important, it is very precious to our nation. So that quality norms, quality standard, it has to meet. So how we can go with that? So we can engineering approach rather than theoretical approach, we can consider doing the testing requirements. We can make the testing facilities with defense public sector or DRDO or the industry. If they can also come up like enable accredited labs or defense accredited labs, they can come forward. We can test it, our materials or vendors' materials at their ends. Then national test resources in case of the cost-intensive testing setups. Then educating the industry to the requirements. Then another is like a long development cycle time and gestation period. See, because it involves various agencies, it's not that industry come forward, they supply the sample and we can just use it, that one. I told that procedure. In that procedure, there are the government agencies are involved, right? Like a DJQA, RCMA, DRDO. In that, how we can go ahead? Like actively we can base the close project monitoring and the concurrent production. And defense public sector can also fund the development-based maturity level and industry and successful execution of the project in the past. Industry needs to accept the challenge of the investment. See, the thing is that initially, this is a defense public sector. So government cannot come and immediately, like a public sector, can provide the money and they can start working on it. So initially, vendor has also come forward for their own investment, their own setup to further come forward so that they can give us the confidence, yes, they can do it, so that public sector can also give the confidence, yes, they are able to do it and they can, so that we can support in that way. So it's both the things, win-win situation, we have to come forward. Then the technology gap. So whatever the aircraft and that has been developed quite like long back in that other OEM countries. So there is definitely a present technology and this what we are using, there is definitely a technology gap. But we can cover up this technology gap by close industry academia interaction as well as taking DRDO and DPSC into the confidence and in domain-specific knowledge with industry in order to empower them to appreciate the intricacies of the sector as well as accept the challenges of the indigenous development. We can encourage the innovation in the industry sector and strengthen the innovative ecosystem in the country also. Then what is the scope? This scope is, this exists a good scope for the indigenous development for the airborne equipment. Airborne equipment means that goes into the aircraft during the flying. This industry has a long gestation period, even if we have to take a patience as well as the willingness for that thing. Industry requires the stringent quality requirements to be met with, which can be addressed by domain knowledge sharing, test facility sharing. Then engineering approach by all synergic manner than theoretical requirement attitude. By nurturing the aerospace ecosystem by all stakeholders, including the academia. Government of India is liberalizing policies to support Make in India program. The industry needs to accept the challenges in terms of the technology upgradation and investments. So I'll just come one of the examples how we can go ahead. One of the big project that is canopy sealing hose, that is an inflatable seal. You can see that seal, it is on the canopy side of aircraft that is fitted. You can see this one. So that is a complete seal which is been used on that aircraft, and when aircraft closes that canopy, that pressure is maintained into it. So that consists of the, you can say a tube which is desired shape having the layers of the fabric reinforced with the rubbers, and nitrogen gas is passed into that, and so that it can maintain that gap and it does not allow outside pressure to come to the canopy, and it should maintain the canopy pressure so that pilot can fly for more than 1 and 2 hours. So the challenge was that it is around 7 to 8 meters of perimeter, as well as it is having particular dimension, it is having the specific contour, and it is basically the rubber fabric interlayers. And it has to, when we apply the pressure of 2 kg per cm square, it has to inflate and it has to maintain that particular gap in the canopy section. So the basic challenge was that we can extrude the product in a longer way, but it is a compression molded product. So how we can manufacture that? How? This is the first time in India, none of the vendors or none of the company has tried. We took up this challenge for development of these things, and we faced a lot of issues for the mold manufacturing, to the material selection, to the all technology. Like OEM is giving like 2 times we have to replace in a overall, like in 10 years we have to replace the 2 canopy sealing hose. One ceiling was costing more than 10 lakhs rupees. And it is of the natural rubber and cotton fabrics and that thing. Then we have come up with the idea that we can go for the longer duration period material, as well as it should sustain in all weathering condition and it should give the life. So we gone for the silicon based rubber compound, and then terylene fabric and specific adhesives has been developed for that. And we have developed one Tamil Nadu based company. We have interacted with them. We developed the special fixtures. We developed the special materials. We taken the approvals for these materials. And then we have gone for the trials, and many times after it's a big process, complex process we have passed, and then finally we achieved that pressure has been maintained and that is been successfully installed, and that can be approved by DRDO. So that has been approved, and since long 10 years it is flying very well, and we have done almost more than 3 to 4 CR of foreign exchange saving in that case. So you can see the mold itself is having a very critical, it is around 3 meters long mold, and it is a totally compression mold, hydraulic pressure been applied during the manufacturing. Various tests has been conducted during the evaluation, like you can say accelerated aging at 90 degree for 21 days, ozone resistance, endurance cycle itself, 2000 cycles, then minus temperature cycle, high temperature cycles, burst pressure, radiation test, mechanical properties. After each and every testing, then flight trials actually conducted with that seal, then pilot has given their remarks, satisfactory, and after everything it is running. Then you can see what opportunities for the vendors. So vendor have a lot of opportunities for this aircraft parts, materials manufacturing. You can see we are focusing on identification of the suitable vendors within the country at all levels. Presently, we are having more than 2,500 vendors. And you know that government is giving make one, make two policy. Now you'll see what is make one and make two policy. Make one policy is like that, suppose I wanted to develop some of the material, rubber compound I wanted to develop, and your company come forward to development of that. Then we take their quotation, their feasibility study, everything that is, and after that, we give you the money for that development as well as further bulk supply for the prototype, everything, after you selected as a L1 vendor. Then procedure starts. We give you the testing charges, we give you the development charges, we give you the prototype charges, everything. After all satisfactory testings, evaluation and approval, payment gets released, and vendor also getting that payment. That is a make one policy. And second is a make two policy, where we ask the industry, you develop your own, you put your money, we give you the technical support, we give you the everything, whatever the required for the material properties to be achieved, technical data will be shared, and you develop your own. You come forward with your all development, you do the testing, you do burn all your testing charges and everything. And then once your prototype, everything is meeting all the requirements, it has been tested, evaluated in the same procedure, testing evaluation been done by in the same way. And once it is okay, approved, we assure that ki further bulk requirement, whatever the requirement will be there, that requirement will come to you. So whatever the expenses you occurred during that stage, that can be covered up in your further bulk supply. So that's a make two policy. And in our HL website, if you can go there is a make one, make two portals, and in that portals we have listed number of items which we wanted to develop through the industry. So if you visit our hl-india.co.in, there you will find these details, the number of materials, items, its yearly requirements, it is tentative cost, everything. And if you face any issues, there are the peoples who are the concerned peoples and the number of that peoples. Then government has initiated another portal, that is a srijandefense.government.in, where whatever imports suppose I wanted to import some of the 10 materials, I have to ask the government, I have to ask, import this because these are the critical. Then government permits, but simultaneously they tell ki, now you start development of this material, put it in that Srijan portal, and let us ask the vendors to come forward. So whatever we are targeting future, So that materials are also put it in shrijan.defense.government.in. That is under Ministry of Defense, MOD, and where you will find that which are the items for the further indigenization and which are further importing. This is not only the HL, but all other defense public sector, they are also putting their requirements in this region portal. So the vendor has the opportunity not to run anywhere. They can see on this portal what are the things they can take up for the development. They can discuss with the concerned people. There are the email, phone numbers are given there. So it's easily they can approach the requirements. Then development of MSME vendors, they can provide the maximum supports to them, indigenization, outsourcing, technology development. In the commercial process also, we help them in a very larger way. Then collaborating with DRDO labs, Premier Educational Institute, and development of latest technologies indigenously. So we always urge to the Educational Institute also, DRDO labs also to come forward. So with the better materials and polymers, we expect a stronger reinforcement, means industry is our business partners. So it's a better process reliability, tolerance, capability, control, better. So innovation which is required, which is needed. So we expect industry to come forward for this development process. And many of the industry has already working with us, and many of the new technologies, we are also ready to adopt that technology. We are also ready to see what are the latest trends which are going on. Not means it should meet the basic requirement, as well as it should meet all the specific requirements. So we expect the polymer industry that is coming under non-metallic and consumable, which I have discussed, they should come forward, because this is the area which has been expected, which is not yet focused yet, but it has a very huge capacity, huge capability. As Radhakrishnan sir has been told, our LC aircraft, around 45% of composite material it has been used, and they have already mentioned in industry standard all the military aircrafts and as well as the, you can say, transport aircraft, 50% of composites are used. However, in our LCA case, we have used almost 45% of composite, and still we are working on it. And it is really a great pride to our nation. This LCA, we are manufacturing 83 LCA orders are in. We are already in our manufacturing stage, as well as some second line we are planning in our Nasik division also. So in the helicopters also, there is a huge scope for the composite materials for the development. And Bangalore division is especially working on that. So we expect industry, by this forum, I expect industry should come forward and let us work together for the betterment of our country, for our nation. Thank you very much. Jai Hind.
Thank you, Hitendra ji, for setting the tone. And we will have a small Q&A session after all the speakers have done their presentation. May I now request Mr. M.M. Biswal, Business Head, KLJ Polymers of the Polymer Engineering Plastics Group, to please present his thoughts.
Namaste, the speakers on the dais and the delegates. The topic is polymer and advanced materials in defense applications. And the agenda is like this, that introduction and about KLJ, then polymer in defense, selections of materials, how we select the material, few case studies, and the products we offer. Yeah. Welcome to the KLJ group. And servicing, we are servicing for since from 1967, maybe around 55 years to the nation and the world. The largest manufacturers of the
and the market leaders of the plasticizers and polymer compounds in South Asia. We have largest manufacturer in the chlorinated paraffin in the globe, 1.4 million ton per annum manufacturing capacity, turnover of 1.4 billion, modern infrastructure with very high degree of R&D facilities and manufacturing facilities of state of the art, and more than 2,200 workforce, strong workforce who runs their own business. These are the certification we have. We have ISO 9001, everybody knows, IATF. This ISO 17025 is for the laboratories. Actually, all our laboratories are NABL certified. Then we have environment certificates. We have FDA, that is food and drug materials like chlorine molecules. Then we have ISO 13485. This is basically for the product development, and that is why we are also certified by the DSIR, Department of Science and Industrial Research. We are approved by them for the fundamental research. We have kosher. Kosher is actually the polymer what we make goes as for the Jewish food and chemicals. So that is kosher because we do a lot of exports. So we have to meet kosher. Then we have GRS, that is the green polymers. That is what we have, global recycle standards. We have that certification also because we have to save our Mother Earth from this pollution from the plastics, whatever you tell. Then we have halal certification, where we also meet the Arabic laws and principles on food and beverage, because our lot of practicals goes for the products goes for packing applications. Then we have healthcare and safety certification. One of the largest manufacturer of the compounds for healthcare and safety in the country. We have operations in around three countries. One in India, we have 6 locations manufacturing, and we have a Qatar plant, and we have a plant in Thailand. We have distributions more than 400 cities and 90 countries all over the world. This is our worldwide presence. This is not the presentation. Excuse me, this is presentation, I think, jumbled. You have to give me the other one. Okay. The polymer compounds, so what we have is around 2 lakh tons polymer compounds in Silvassa, and there are around 75 extruders what we have. And we have new facilities in Agra because we are a lot of products for the shoe soles applications, and Agra, Kanpur and Delhi are more towards the shoe soles. We have extended R&D facilities, backward integration to plasticizers, and we have phthalic anhydride plants, which is backward to plasticizers, and the compliances like REACH, ROHS and all. Then we have process controls. We follow all the statistical data and all for very fine-tuned process control, which can give good quality control on the constant products. That when you get a product, you get a quality product and a continuously the same products, constantly same products. Executive customer reach we have, and long-term and stable alliances, maximum application covered, and multi-locational manufacturing facilities and high-capacity automated plants. Now, the polymer compounds what we have is mainly PVC, polypropylene, engineering polymers, Cyoplast, peroxide, semiconductive, then EPR, XLP, ZHFR, that is zero halogen-free compounds, polyolefins, SDP, TPR, TP, EVA, PVC, PE, and universal master batches. The application where we go is automotive, railways, flexible profiles, SPE coatings, packings, flexible and rigid moldings, then automotive, electrical, electronics, hygiene, engineered materials and sports and minings, appliances, wire and cables, irrigation, floorings, rigid pipes, then defense, footwear, stationery, and healthcare, heating pipes and gaskets. These are the engineering plastics we make. That is the Kerin compounds is our compounds on polystyrene. Then we have Kester, we have the polyesters, and then we do a lot of alloys like PCABS, PCPBT, PBT, PET. Then we have Corail, which is the polyethylene ether-based, that is the PPE plus its blends. Then we have Kylon. There we have K blends, that is blends like nylon 660s, PBT, PET. Then we have Kirins, those are styrenic products. And in styrene is where we have the different glass fiber fields, carbon fiber fields, mineral fields. Then we have PC, polyacetals, then polycarbonate and polyflex, where we cover all our TPR, TP, TPU, and TPVs. This is our matrix where we have the products and which are the products we have. Then research and development, we have state-of-the-art equipments, then 55,000 square feet of R&D facilities available, and application development of different like APIR, DSC, DGA and all, and this is open to our customers and who want to do any value engineering as well as import material substitution. Now coming to this, the polymers. This is what is the pyramid of polymers. Now, when you talk about polymers, there are standard polymers, which is called as the commodity polymers, that is PMMA, Ka, PETG, PVC, PS, ABS, PP, SDP, and LDP. And one side of is crystalline and one side is of amorphous. Crystallines are mostly of high mechanical as well as it has translucent or opaque characteristics, whereas amorphous is more in transparent. The next category comes to engineering polymers, where we have PC, TPU, PPO, PMA, PA, POM, ultra-helical polyethylenes, and PAT and PBT. We have in this grade, we have the polymers in engineering polymers, and now the high-performance polymers, where it is polyethylamide, PES, PPSU, PSU, PPS, PBDF, PTFE, and we are working on this, have few polymers, but there are very high ultra-performance polymers, which has polyimides, polybenzoyl and PAIs. We have not still worked on that. These ultra-high polyperformance polymers and high-performance polymers mostly goes for the defense applications. Now, when you tell it is, what is the standard polymer and engineering polymer and high-performance polymers, mainly this is like the service temperature, the chemical strengths, and what we have. If you go to a standard polymers, your service temperature comes around 75 degrees centigrade. So if you consider that your polymer has to be used in the service conditions of 75 degrees centigrade, then you will go for a standard polymers. The engineering polymers goes up to 140 degree centigrade service, and moderately these are resistant to chemicals. Now similarly, the high performance polymers will be around 240 degrees centigrades and very good high chemical resistance. But the ultra high performance polymers, those who have 350 degrees centigrades service temperature and have highly inert many of the chemicals. So this is what is the new generation polymers, where it goes is density to the stiffness, the properties of the material to its densities are very low. Now, why polymers in defense? The polymers are in defense because it is resistant to grease, fuels, and other chemicals, ESD protection and EMI shielding, enhanced stealth due to in-segment radar and infrared structure, may not need any painting or finishing, sub-zero impact resistance, anti-corrosive, reliable and durable, modular replacements, reduced weight, reduced noise and vibration, self-lubrication, resilience and impact resistance, improve aesthetics and transparency. These are the uses, these are the things what defense also needs, and polymer meets those things. Now, when you select a polymer, select a material for any application, whether it depends on other application, what we do is first narrow down what is the requirement to his functional properties, and then see that which functional properties does not meet in that particular polymers, so discard those polymers. Then come to the polymers again and see that priorities wise which polymer is suitable that, and again go that in the past or history which type of application or application related to that is in that material, which comes to the decision that what polymer you are going to or what material we are going to use. Now, if you see this case, you have the natural, there are 5 or 6 materials what is available for the industry to select. One is elastomers, one is foam, one is polymers, one is porous ceramics, one is metals, one is technical ceramics, then composites and natural materials like woods, glass and all. Now, when you see this is the curve of Young's modulus versus your density. Now, when you see this, you get the material in the spread that which comes to the different region. Now, polymers and elastomers comes to a region where it has very low properties of modulus, Young's modulus, where you have the material on the top, the ceramics and all, which have very high the modulus, but then these are also bad thing like that, these are all the brittle materials. Now, when you consider for a designing, now if you see this E by P constant and E by 1 by 3 constants, now anything, any modulus above the top, E by B constants, will take a polymer which is mainly go for the ties, like the ties, strings and all, for these applications. Now, when we go for 1 by 3 P constants, it goes more, the left-hand corner of those materials you have to select, which goes for mostly to the stiffness and place type of structures. So, while designing a polymer, is a materials, we have to choose that which types of material we have to choose for that product. Now, the designers, when they choose the material, they don't only see the material, they also see the impact of that material, whether it is safe to produce, whether it is safe for the environment, when there is a personal health, how much carbon emissions you create while choosing that material. Those are also now the concern of the designers when we select the material. Now, if you see the specific strength of high performance plastic versus metals, now why now plastics? Now, if you see this, one side we have taken the specific tensile strength of the polymers in the x-axis, in the y-axis, and in the x-axis we have taken different polymers, different materials available. Now, if you see the ultra high engineering plastics, like advanced polymers like PAI, polyamide ethers, and those have very high specific strengths, even though the specific strength is much higher than the aluminum and magnesium. So, and if you consider for the glass field peak, it has around 1.6 to 1.7 specific tensile strength, when these metals have lower, at least 1.4. So when you consider the designing a product, now you consider that what type of product you have to take while designing our product. Plastic becoming the lightweight becomes the first choice nowadays for all high-tech engineering applications. Now, if you see an example of the selection of polymer, now there are many polymers from where you can select, but if you see the criteria of water absorption, then you have to come down to, narrow down to that these are the certain polymers only you have to go. Then you have to go for service temperature, then you go to narrow down that these are the polymers which we can go for these applications. Now, if then chemical strength comes, then you have to narrow down, and finally, by your historical examples or something, you can say that these polymer we have to decide for this application. Now, if you see the thermoplastics in the aeropress, the highest thermoplastics in the aeropress is covered in the commercial aircrafts. Maximum polymer is in there. But if you go, that if it is in our defense and our jet engines and all, then you see it is around 12% and 4% and 4%. But there are a lot of scopes in those, if you see the military, it is only around 7%. There are a lot of scopes with the advanced polymers where we can go ahead with a different super engineering polymers, and we can increase this definitely the share in aerospace. Now, mainly for drones and all, which are where it is coming, where the lightweight is the major factors, we can go ahead with a high, really advanced and super engineering products. Now, this is the polymers in military and defense. Now, if you consider polymer PP, the polymer PP in military and defense, the unique property is it is the lightest weight material on the earth, and it is resistant to heat and chemical and resistance and very tough and highly cost efficient. This application in the military will go, the military grade containers, heavy duty ropes and ties. Now, if you see the peak polyethylene ketone, this is very highly, this goes under the most advanced polymers now. It has very high thermal stability, low moisture absorption, resistance to absorption and chemical absorptions. The application can go the aircraft components like and seals and electrical connectors and pumps and impellers. Now, if you go to POM, this is also used in the military and defense applications. It is rigid resistance to chemicals and moistures and low coefficient friction and cost efficient. Mostly gear slides, guides, cams, rotors, handles, bearings, plumbing, and all plumbing components are made out of these polyacetyl compounds. Now, if you go for thermoplastic elastomers, now the thermoplastic elastomers are many kinds. Now you have thermoplastic elastomers. Yeah. Okay. Then we have polycarbonate and polyamide 6. Then PBT, PET, rollers, gears, and cams. These are extensive where we are go ahead with this. If you consider about the advanced polymers in the military and defense, this 30% glass field is highly used carbon. 30% carbon field material is now mostly used in the aerospace and defense applications. And this is one of the things that we are in our India-made LCA Tejas. We have the glass components, aluminum, Kevlar, and carbon components, where the CFC components is around 40% carbon composites. Now, this is a typical composite structure of the military aircrafts, where these are the different parts where we have used a lot of engineering plastics and advanced plastics. If you see the polymer versus metals in the aircraft, the composites comes around 53%, and these are the thermoplastics in aerospace and defense, where these are the components which can be very well and already made in defense and aerospace. Products what in KLJ we offer is, we are offering now 10% glass field FR components for the development of landmines, and these silent features are UV stabilized, and it is V0 rated is 5 VA and high modulus and available in various colors, and mostly to 2 colors goes for the defense. We are very much closely doing this defense for these developments, and it is now approved. Then if you see this application is the wears for the detonators, and many cases these are all the high stability wears and high temperature wears with the good surface finish and mechanical properties. Then this is the PVC compounds we give again for the wear applications and goes to defense. This is a TP compounds. What we have is snow boots, and this is the characteristics. It can go from -40 to -50 degrees centigrade. So the glaciers also you can use these shoes. So we produce this, and it also goes for exports and different applications. Then future developments, what we is the reinforcement engineering polymers, foaming grades of polymers for low weight, self-lubricated engineering polymers with low dynamic and static friction, high performance polymers for extreme heat and good chemical and ozone resistance, special grades of TPV and TPGs, and special grades of cable and applications. Now, the request is now that with defense, if we, the raw material manufacturers like us and the product manufacturers for the defense, we can join our hands together, we can make definitely many products and many cutting edge products, even though we have the technology. We can't tell that we don't have the technology, we have knowledge. We can definitely supersede developing the products for our defense and meeting the Atmanirbhar Bharat programs, and we have knowledge, we have technocrats which are much better than for any foreign countries, and I hope we will do this. Definitely we will do this. Thank you everybody, and Jai Hind.
Thank you so much, sir. May I request Dr. B.B. Kale to please come and take the stage. If the speakers would like to, if comfortable, otherwise.
MCCI 28. Thanks to MCCI and for giving us opportunity to present our R&D work. Basically, we are R&D people, not the industry, this one, but it's all materials development activity we have, and portion is, I can say 25% is for strategic sector. So there are many materials which required for the strategic sector which we are developing and also supplying to them. And few of them are very, very important, which only this unique development which I'd like to mention today. In my talk, I'll just, we have many materials because this lab is established only for materials development to the strategic sector as well as electronics. So I'm going to talk on this all. So I have selected few development which we are doing for this strategic sector as well as defense. So this laboratory is basically started only for materials for electronics, and vision was to have the materials development at pilot scale so that industry can take up further and produce it. So we have 3 laboratories. We are in HQ in Pune, and Pune laboratory is working on all kind of nanostructures, material as well as polymers, organics, specific organics for electronic applications, strategic sectors, composites, then glasses, which include also glass composite, polymer composite, and ceramic composite, so which is really required for variety of applications. Then we have a very good facility for integrated electronic packaging. See, electronic packaging is a very, very important sector where we work for strategic sector as well as because this started this low temperature co-fired ceramic based electronic packaging, which has been started with defense. Defense has funded this project in 2005, and we have created this facility for integrated electronic packaging. It's a state-of-art electronic packaging in 2,000 square feet clean room facility. All equipments are housed in the clean room. And now it's, initially we did for ISRO and DRDO. Now we started, we are very open to the other electronic industries which are would like to work on this. Then these ultra high purity materials, 99.99, 7N purity, 9N purity, and 12N purity, which is really required, the scope of the DRDO in some of the devices they required. So we have the facility to make 7N, 9N, and 12N purity semiconductors as well as metals refractories in our Hyderabad laboratory. We have developed this, and we can do up to pilot scale from 1 kg to 5 kg. Then all kind of renewable energy materials we do, energy generation materials and storage materials. In generation, we have solar cells, fuel cells, all this technology with materials. And the new concept which are going to talk today, we have done in our laboratory is packaging of fuel cells in low temperature copied ceramic based ceramics, because it's a sturdy packaging. Then energy storage, we have batteries, all kind of batteries we do with materials, and we have a supercapacitor facility, because supercapacitor is very, very important for the defense applications. We do all kind of sensors, including gas sensors, magnetic sensor, pressure sensors. We developed it with materials. They are in normal packaging. They are also in LTCC based packaging. We have IoT sensors. We have a center of excellence in IoT sensors. A very important area where I started additive manufacturing, where all kind of 3D printers we are going to design. There is an industry along with this additive manufacturing, where our role is to develop materials, metals, powders, then ceramic powders, semiconductor powders, then composites, polymer composites, glass composites, ceramic composites. So all these materials with their inks we are developing with small scale to large scale, because today additive manufacturing with 3D printers, all 3D printer people importing all these materials. So we would like to indigenize these materials, whether it is metal semiconductors, metal oxides. Polymers is well known in that. Basically started with electronic components. Then we have graphene materials and 2D materials center of excellence. This is a national program where we have graphene manufacturing, or we have developed in large scale. And we have the industry hub along with us in our Trichy laboratory. Our laboratory, one of the laboratory in Trichy, they are working on all kind of ceramics. And in Hyderabad, we do all kind of metals, high purity metals, from 4N purity to 12N purity. So in this laboratory, we are working on this graphene, and we are developing applications of graphene, whether it is for whether for the electronics application or strategic sectors. Then quantum materials and technologies. So in future, we will have the quantum technologies. There are for many quantum communications, quantum sensors. We have already programmed on this, and we started working with materials. So materials are very important in quantum technologies. So quantum dots, quantum wires, as well as 2D materials, which are going to play a role in these quantum technologies. And we are going to develop within 2-3 years. And this also along with the industry, because Intel and other companies also associated with this, because they are because qubits, all kind of qubit, 12 or all kind of specified qubits we are going to develop in this program. So first I would like to emphasize on the energy storage, because I have very selected very few because of time is less. So only 10% of our work we are going to, what are maybe very focused to the defense that I'm going to present. See, we have the storage, energy storage devices. This one, we have a center of excellence on rechargeable batteries. All kind of rechargeable batteries we develop in this. The vision of this center is to develop all kind of rechargeable batteries, whether it is lithium batteries, sodium-ion batteries, lithium-sulfur batteries, aluminum-air batteries, aluminum-ion batteries, and iron batteries. Now we have also introduced the next generation battery like organic batteries, because organic materials can be designed and we can focus the capacity of the material, whether it is cathode or anode, and it is in our hand to produce or synthesize the materials of specific capacity. So that area we are a very important area, is because till date we do not have the cathode material which can go up beyond 140 to 145 milliampere hours per gram. So we thought that this is the best area. And then we started working with organic electrode, then we started with peptides, then polymers, ionic liquids with polymers. So all these things really helping in the batteries. You know, it is a material world, and we have so many materials and with so many applications, so many properties. So our job is to see the properties and examine the application, whether it can go, because we found some of the material which will be useful for solar cell, it will be useful for battery, it will also useful to the supercapacitor. I mean, see, the properties of material is very, very important, and it shows that where it will go. So we have a state-of-art characterization facilities of materials. We develop new materials. We do simulation of the materials with doping. Then we can also design the cathode, anode, or any other kind of materials with the simulation, and we produce it at fairly large scale. So today we have the problem of cathode material and anode materials, which still we are importing from China. We developed up to 500 gram scale, 1 kg in our pilot scale. This is ready for who may be coming for the lithium-ion battery manufacturing. So these people will have this material to be used directly in their making the batteries, or we can say the fabrication of cells. We can make the cells with so many cathode materials. There are many chemistries, NMC is there, LFP is there, or now people are talking about sodium-ion batteries. So sodium-ion chemistry has come. So all these chemistries are very, very important for these battery applications. So this is actually lithium-ion battery with modification of graphite. See, we have a lot of graphite we are producing in the country, like graphite indelimate and some carborundum, and all these people have graphite, but we need to see that whether this graphite is really useful for the battery. And then we are modifying their graphite for the battery application. So we did that, and now there is a source of anode material in the country as a graphite materials. So here we have, the all fabrication facilities. So we can make single cell, which we are importing now, and people are making batteries. Now we have a single cell fabrication technology. It is open to all. So we have made single cells and made batteries, up to two-wheeler battery, we have run the two-wheeler battery also on this. And this technology is open to all, single cell technology. Any startups, those who are interested. So we have made 3 parts of this. One is material part, because those who are manufacturing, those who want to manufacture the batteries or assemble the batteries, they may not be interested in the materials. So all type of cathode, anode, and electrolyte, we can have one technology. Another is a fabrication of electrodes. So somebody can make the electrodes and keep it, and those who are manufacturing or assembling batteries or fabricating batteries, they can sell them as an electrode. And third technology is actual fabrication of battery. So all 3 technologies are ready with us, and now we are going to, being a government, we cannot have the exclusiveness. It's a non-exclusive. Anybody can come and take this technology. Sodium-ion battery, we are very close for the announcement of the TOT of this sodium-ion battery, because we have reached up to very close to the lithium-ion battery, but still we would like to refine it, confine it to for the commercial scale. And within 2-3 months, I think we are going to announce these technologies with materials, with our own materials, cathode, anode, and we can make button cells, we can make pouch cells. Now we can also make cylindrical cells. All these things we can do under the one roof in this center of excellence. So this center of excellence of batteries is open to all. Those who want to go, want some training on this, we are very open to that under chargeable basis. Then Lister Surfer batteries are high capacity batteries. This is only for stationary application. We cannot have in the two-wheeler or three-wheeler, but for stationary application they are very good. So this technology also we have developed with materials. All this you can see the capacity of 250 to 300 milliampere hours per gram. Quite good. Then we made use of polymers, ionic liquids together, and had a very solid polymer electrolytes, which really helping, so that in battery problem is the safety problem, because of we are using organic electrolyte, and that because of this organic electrolyte we cannot charge the battery fast, because when we charge the battery fast, temperature is increases, and this whatever may be organic electrolyte which contains solvents, organic solvents, they get evaporated within that, and there is a chances of explosion, dendrite formation due to the due to the reaction of electrolyte with the organic electrolyte. So we developed solid polymers, and now we are going to have solid polymer batteries, lithium-ion batteries in the market very soon. We are going to announce this technology also. Considering the flexible devices coming in the market, we started working with flexible batteries. So all these flexible batteries also we do with, now we started with the polypropylene and polyurethane as a substrate, and totally flexible batteries we are going to make using our materials. Then supercapacitor is all kind of from 20 farad to 500 farads we are making supercapacitor. And recently we have given the technology to ERD, the supercapacitor for time fuse application. So this is required in our missiles. So we got the prize from the defense for these applications. And now we are able to do all kind of all capacity supercapacitors using our facility. So this technology is also available. We can use aerogel carbon in this. We can have graphene. We can have carbon nanotube. So all these things we combine together and had this technology. For the defense and for the atomic energy, we are having the micro substrates, all kind of compositions we have from 4 dielectric constant from 2 to dielectric constant 17. And these are unique materials and which can also have flexible substrates on this, and this is already DAE is using these materials, and some defense like CL, other people also doing that. So this is a very unique development. All NAVIC antennas we have developed. This is a replacement for a GPS with materials. So it is with ISRO now under testing. So as soon as ISRO is giving green signal, we can announce this technology. We can have all kind of sensors. So the temperature sensor from -70 to 1000 degrees centigrade we can do with composition, and pressure sensors, piezoelectric sensors, and all these the temperature sensors for the defense also we have given. ISRO, this is one of the application in the ISRO from -70 degree to 1000 degrees centigrade sensor, very tiny sensors, we can see that. Then this piezoelectric material, like for the piezo actuators for use in breathing regulators of air, is a new concept we developed, and this is for the this technology also we have announced. Hafnium is one of the very good material which can go up to 3000 degrees centigrade, and hafnium is not available in the country. Hafnium is available along with niobium. So NFC is manufacturing niobium oxide, and they produce this waste of 25 ppm hafnium. So we extract that material from that waste and producing 320 kg of hafnium every year for the ISRO. This material goes in this is a nozzle you can see. This nozzle is made up of zirconium, titanium, and hafnium. So every year ISRO required 320 kg of hafnium. So we are supplying them under MOU. We cannot sell the material because with R&D we can just transfer the technologies. Being a strategic material, we are supplying to them under MOU 320 kg. Earlier cost of this zirconium was 4 lakhs per kg. Now it is 90,000 rupees per kg. So cost has come down because of this development. We are really proud of this material because our Hyderabad team did this job. This is the process. You can see extracting from 25 ppm solution to making 320 kg of hafnium is a very laborious job. So we have now how we can atomize them, that we are putting more efforts for this. This is the ultra high purity materials for missiles. We have boron carbide, silicon carbide, titanium boride. All these very specified materials we are going to manufacture in this. We are making silicon carbide bowls for the defense. They are making silicon carbide vapors along with that, and for their high power electronic substrate. This is the bowls we are making. We can make up to 2-inch diameter. Now we are going to for 4-inch diameter. These are the 12N purity, 7N purity materials: zinc, cadmium, and indium, as well as germanium for night vision cameras. Already we are produced 5 kg batch of germanium 99.99 and 7 in purity, and zinc 12 in purity. Both are required in night vision cameras. We are producing nanometals in large quantities, 100 grams per hour, 200 grams per hour. This is the plasma reactor system we have. We can produce aluminum nanoparticle and copper nanoparticle for the defense because they are using as an oxidizer in the propellant. And this is the aluminum nanopowders we are making for them. Very highly, this may be around 50 to 100 nanometers, and we produce 100 grams per hour. This is the copper nanoparticles we are making. And aluminum nitride substrates are very important in high power moleculators. This has been done this development is only for defense, because where the high power electronics are used, this aluminum nitride substrate has been used there. So thank you very much. This conclusion I have made because there are many things in defense as well as in ISRO, other strategic sector, DA. They really need our help, and industry along with academia may do some miracles. Thank you. So I'm just leaving because of another meeting. If somebody has questions, you can ask.
Any questions? We can.
Yeah, I can do it because I have to leave today.
Sir, good afternoon. My name is Dr. Ranjit Joshi. I'm representing a company called Harisi Private Limited. I am really fascinated by your presentation. Wonderful work. I just missed one point about lithium iron phosphate, which is very prominent in literatures. So can you just comment or make some remark about these materials?
Lithium iron phosphate is really good material for only for consumer electronics. Wherever batteries are wherever batteries are required for the consumer electronics, I can say mobile, or I can say laptops and other UPS systems. LFP is okay. This material can be used as a cathode. But if you want to really go for two-wheelers or four-wheelers for e-vehicles, then you have to go for NMC or LCO, all these technologies. Because LFP has a problem of capacity fading, because when we charge these batteries at a very high current rate, then this LFP get dissociated and we get capacity fading. This may not be required in the consumer electronics, where we don't require a high current rate. Only e-vehicle we require a high current rate.
Thank you, sir. Thank you.
Okay, thank you.
Sir, since you have to leave, I guess, let me take this opportunity to present a small memento to you.
So, my number is there with the organizer. If anybody has the interest, they can, or email also is there. Thank you. Thank you.
The next speaker, Shri Ashok Kumar ji from Ahmednagar.
Slide changer चाहिए तो slide changer. Yeah, good morning to everybody, and thank you for MCCIA and Indian Plastic Institute for giving me opportunity to be here. Today, actually what is happening here, the speakers are enriching our knowledge on advanced polymers. So, there is a lot of areas and applications are coming here. And then I thought I will speak about something different. All these materials we can see it is tangible materials. There is another aspect of these materials are called intangible aspects. Why I am covering intangible aspect? Government of India, our government is trying to promote defense export, and lot of schemes are there. One is called the Defense Testing Infrastructure Scheme. Another is Defense Export Promotion. Another is Mission Rasha Gyan Shakti. So hence I thought it will be very prudent to speak on intellectual property rights. That is intangible. We cannot see of these products. Defense is a niche market where the first problem is the quantum of is very limited. So that is a major problem, always the manufacturer is coming out. So we are only looking into the product side. There is another aspect of the product is called intellectual property side. Why we cannot exploit it? Why we are not looking into it? That is the thing which I want to, how it can be correlated with indigenization and advances in polymers, and how the vendor can be onboarded it. How they can be bring indigenization aspect into exploiting the intellectual property part of it. That is my thought process for today's session. So what is intellectual property? Everybody knows. It can be invention, literacy, artistic work, design, symbols, names and images. It is a creation of mind. And it is protected by law to a certain level. It is protected. The protection is given to foster innovation, to create an environment of innovative environment. So it is protected. So which are the areas our polymers and advances in polymers can be covered in this intellectual property types? These are the 5 types which we can cover it. One is industrial design. It is actually an ornamentation. Nothing but it is not related with any what is called functionality, like textile design and packagings. This can be covered here. So next is trademark. Everybody knows what is trademark, to differentiate to business. Then people are asking the question, why trademark is need to be registered? Why it is required? So if you don't register it, it is very difficult for you to claim later on if somebody registers it. Unregistered trademark, it will go to infringement. You will lose your intellectual creativity. So it is better to have a register it. So next is the copyright. Copyright is nothing but whatever is fixed. There is no registration required. The beauty of copyright is that it is universal. So if you fix anywhere, that itself is give the right. So many things in our industry like brochures, handbooks, even websites or advertisement, everything comes here in this category of copyright. Once it is created, the right is already generated there. So another aspect is patents. So here only I want to cover a little more about it. So it is a geographical. There is nothing called universal patent. That means if somebody get a patent in India, that will be applicable for only in India. So if somebody is taken a patent in US, that patent is, if you are copying it in India, nobody can challenge. So infringement action will not happen in that case. That is the first thing we have to remember it. So, and the life of a patent is only 20 years. So what is a patent? It is an exclusive right granted. It is actually a negative right. It doesn't mean that you should get a patent and do the job. It is excluding others from. Nobody else is allowed to do it. Whatever for making, using, or selling, or importing the patented products. It is a negative right. So, now I will tell condition of grant of patent. How, now the question is indigenization, and what is there any hindrance to grant of patent? There is 4 conditions are there. One is new or novel. In India it is called new. In other US it is, the term is used in novel. What is new means it should not be known to anybody, or there should not be any record. It can be any paper or anything, no patent or no website, no paper, anything. Even cartoon can destroy novelty of a patent. That is new. That means when a patent we want, we should not tell to the world first. We should file a patent application first. Then next is non-obviousness. Second criteria, non-obviousness, is very simple. There should be a surprising element. It should not be something which is not anticipated. Like earlier, we never thought that telephone will work without wire. Suddenly somebody came out, yes, it will work. That is called non-obviousness. And third criteria is called industrial application. India it is industrial application. Somewhere it is use, like US. It can be personal use also. So it should be industrially applied. That is the condition. Now fourth is exemptions. Exemption is across the country it is different. In India it is Indian Patent Act 1970 section 3 and 4 speaks about exemptions. 3 speak out around 12, 13 conditions like patent should not be will not be granted for perpetual machines, business methods, then for treatments, literary work, so many things are there. Every country got a list of things which says that we will not give patent for these kind of things. India it is atomic energy, some areas it is related. Some countries it is giving, like Japan, they are giving for computer programs, whereas India computer programs is not covered. So we have to know that where it is there. So these exemptions are there. So this is about the patent subject matter. Now where the patent we will get? One is for product and another is for process. So now I will tell you one thing. If you search a Google patent, around 20 million patents are, we can see out of that 25% contains the word polymer. That is the strength of the polymer segment as per se called the to get a patent. So that means there is 2 categories are there, products and process. So in a polymer, we know there is a lot of polymers today, the discussion is going on, a lot of polymers are there. Even a small modification, even a small improvement can create an innovation. So simple, I will tell an example that natural rubber. What is great in natural rubber? It is known for decades. But the patents are coming for natural rubber blended with nano materials like clays, nano clays. Patents are coming for now with removing the protein from the natural rubber and getting a better properties. So much of small improvements, or it is maybe a great change also. There is a lot of polymers are there we are using. Improvement can bring a patent. Then additives. In any other technical field, everybody sitting here knows the polymer field got the n number of lists. Even a formulation will contain minimum 10 to 15 additives. There is no dearth of additives. No other segment, I think, this much additive is there, except cookery. So any change in additives, for example, a simple sulfur, there is a soluble sulfur, it is around 20 years back, patent was there. Now it is expired. So additives, any change in additives gives an opportunity for a patent. Then machinery, where it is extrusion or injection. What we are doing, we purchasing equipment and we are modifying it for our problems. It happens. But we are not thinking that we done something which is a modification, we could have got a patent. So that is another area where we are lagging. I will tell the figures how we are lagging it. Then products, everybody knows, polymer products, we can have a patent. Then coming to the process side also, same thing, process can be patented. And additives process, product manufacturing process, and even formulations. This process generally, you may be, we are hearing about this evergreening of patents in pharmaceutical segment. There only generally product processes are patented, but here we can do the patenting. We are thinking, if you do it, somebody will grab it or not. So if you read the patent, I will tell you that. I will come to it. So what we suggest is, we should have a patent search first. When we are going for an indigenization, we should do a patent search. It is entirely different between a Google search. If you search a Google, n number of millions of documents will come, we will start searching, we will not get anything. Ultimately, we will waste time. And entirely we are going through a Google search. Whereas a patent search is entirely different. The beauty of patent search is that we will tell in government, there is a BRFR system. Backward reference and forward reference, we call it, if you get a document. If you get a patent document, so we will get a backward. Who started that invention? What the current level of invention to that? So we don't need to search for every document. The patent document itself is giving what is the original, we can go forward it. So the patent search is not a single word search. It is a classes are there, subclass, groups are there, around more than 1,000. So if we are searching for a patent, if we take the class and subclass and everything, if you do a patent search, we will reach that particular segment where maybe 20 or 30 or 40, 100 patents will be there. We can grab full knowledge about that, what we want to do. So that is a great thing about the patent search. And there is one more thing about patent search is that in Google, whatever in the web, the 90% of the knowledge is lies in the patent documents. Technical knowledge is lying in patent documents, which we are not utilizing when we are going for a indigenization activity. So we can, first we can do a Google patent, then WIPO, World Intellectual Property Organization, the patent scope is there. There we can do the patent. And if European patent, I told it is a country specific, there is no universal patent. We have to search, and 38 countries we will get from ESPANET. Then we will get from US if you want patent public search specific to US. Then India INPAS. And there is 6 countries are joined together and there is a global dossier is there. USPTO, then EPO, Japan Patent Office, Korean Patent Office, and China Patent Office. This covers European Patent Office also. So if you search there, we will get a lot of knowledge to do indigenization. So now coming to See, when we do a patent search, if there is no patent we are getting, it is not so easy. So it will take 1 or 2 days, some professional people are there. If you are getting no patent on that segment, you are lucky enough. Nobody done anything and nobody published anything, you may be likely get a patent also. Second thing, if a patent is there also you are lucky. You get some documents, base document for your indigenization work. So then what we should look if the patent is there, then look for the validity of the patent. So sometimes patents are not valid. Every year patent has to be maintained. Fee has to pay it. Somebody may be stopped paying the fees. So it is not maintained. So we can take it. It is a free ride. If patent is valid, again search which are the countries. If it is not valid in India, if the person is not taken patent in India, it is a great opportunity that he cannot challenge if you are reverse engineering it. If the patent is there and if it is valid in India, then we can ask for a TOT. So that also opportunity for us. And similarly, we can patent it. I will tell, if we patent it, so we can also give, next slide I will come. The advantage, here the advantage is, first advantage is monetary benefit. So patent is what a monetary benefit is that it can be unlike any property. If you are selling a land or building, you can sell one time only. Whereas a patent, we can sell n number of times. Depends upon the contract. So that is a benefit. So you don't need to sell anything at all physically. So that is the strength of a patent. Then image. So the image of the organization is increasing. Yes, we got a patent. So some people are there who are capable to do innovative work. And recognition and reward to the innovator who is doing. And we are avoiding free riding. Free riding means somebody will take a patent and they will tell us, please don't manufacture it. So this can be avoided. And last, disadvantage, yes, everywhere is something disadvantage. One is cost. But I would like to tell that in India is one of the low cost for charging for the patent compared to many other countries. And time, it will take time. Generally people have a complaint, yes, it will take time. Sometime it may take 4 to 7 years. The latest case is 132 days also there in Indian Patent Office. So shortest time also there. Time is now coming down. And limited time period for the patent called 20 year. So that is a difficulty. And we have to, public disclosure is required. We have to disclose the knowledge to the public. Then only this is granted. But in the segment of polymer, there is a beauty of that. Everybody knows. Say example, a formulation or anything. If you are getting also, we cannot reverse engineer it. It requires a know-how also along with it. Without that, if it is a publicly, it is a patent is got. It cannot be manufactured easily. So if you are getting a patent, whoever want to manufacture it, they will come back to us for asking for how it is manufactured. Please share the know-how also. So this can be solved because defense is a very small manufacturing. So this can be also sold to the prospective supply, so it can be encashed. Now I will come to the figures, statistics. We can see that in the world, China is every year around 16 lakh patents they are done. So US got around 6 lakh. India got 60,000. I counted how many Indians are patented. Only 5,000. Do we have only 5,000 scientists or innovators in India? We are the populated, highly across the
population. So my key takeaway to you is that everybody can innovate, everybody is creative, everybody can find out a technical solution, because every day we are facing some technical problem and we are finding a solution. It can be an innovative solution is coming out. Hence my suggestion, let the technical problem come, we will find out a solution, and that will be an innovative solution, and we will showcase to the world that yes, India got a strength, we are creative, and we can do it to the world. That is the thing I want to tell you. Thank you.
Thank you so much, sir. May I request Mr. Himanshu Dole from Atul Limited to please join us for his presentation.
Yes, I do.
स्लाइड चेंज करा ठीक.
Hello.
Good afternoon all. On behalf of Atul Limited, I welcome you all and thank you for attending the session. It is my privilege to be here to present this to you. I am Himanshu Dole, taking care of R&D activities in Atul Limited and responsible for development of composites and electrical products. So let's move on to the presentation. So at the end of the presentation, I want you to know about different types of thermosets being used in a defense and aerospace industries, and the kind of metrics comparison we will do. Then we will know about the advantages of epoxy being used in defense industries, and then what are the products offered by the Atul Limited in the defense sector. And later on we will conclude with the Atul's presence in defense and aerospace industry. So let's begin with the presentation, and the first one is we'll see at the development of composite industry. So during 2013 to 2018, it was growing at the pace of 5.8 CAGR. However, it is now accelerating to 6.8 something. There are various reasons because of new applications being developed and the innovations in field of resin and reinforcement. It is easy to replace metal for high modulus applications. So that is how growth is there. And on the upper right corner, we can see the various sectors where composite is used. So it is dominated by construction and electronic industries, followed by renewable energy. However, use of composite in military industries is yet to catch up with the other sector, but it will certainly do that. And if we bifurcate this sector-wise usage with the matrices used in a composite, so there are various matrices. Out of that, polyester has covered most of the chart, like water does on the earth. But my favorite is epoxy, because epoxy has a niche application and most of the high-end application can be served with the epoxies because of its versatility. Now let us, as we discussed, there are various thermoset resins used in high-end applications. Let us compare in terms of properties. First one, and like there are four major class of resin. One is epoxy, other phenolic, polyester and vinyl ester. So we will compare property wise. The first one is like shrinkage. Lower the shrinkage, better the product, because high shrinkage will introduce internal stresses. And epoxy has the lowest shrinkage out of this four products we compared. And the second one is water resistance. Water resistance affects the longevity of service life. Lower the water resistance, better the properties. or better the life. So we get only 0.5% max or 0.2% depending on the formulation for epoxy. However, other products are offering higher water ingress, not resistance. Then next is interlaminar strength. This is the true measure of the composite strength, and this attributes to the polar groups available in the epoxy and the flexibility in the matrices itself. So it has excellent ILSS in terms of epoxy, greater than 50 is possible. However, other material are having lower in ILSS except vinyl ester, which is having genes of epoxy. So because of epoxy, it fares better in ILSS. Next few properties are qualitatively compared, like fracture toughness, fatigue. These are very important properties where repetitive cyclic loads are there. They need better fatigue and fracture toughness. So epoxy is good in that one. And for defense, resistance to radiation is also important. And the next is storage stability. This is commercially important because you need high inventory or to manage inventory if you have lower shelf life. So epoxy can be used up to 5 years in certain cases. So I think epoxy wins the race in comparison. So what are the properties that are required in a high performance application? So the first and foremost is matrices should be compatible with the most of reinforcement. So the second is lowest shrinkage, as we already discussed, high toughness and low affinity. So most of the property that we discussed is required in matrice that Atul products are offering. So what motivated Atul to develop this high-end application epoxy resins? The first one is the growth of Indian defense and aerospace sector. As we know, the current geopolitical situation and the interest of our neighbor in India will certainly drive the growth of defense industry, and we want to capture those opportunity. The second one is till date, whatever matrices is used, we have to be dependent on imports, and they have their own regulations and some strategic pricing. So we always get high price material, which can be a lower price material. Then the next is now, because of globalization, we can have the export opportunity as well. So because of all this reason, Atul went for the multifunctional resin development, and we have two types of business model. One is selling basic building blocks. Who can do formulation by themselves, they can use our basic building blocks. In basic building blocks, we have resin and curing agents, both the class. And for people who can't do on their own, we have formulations also available for said applications. So let us have a look at resin and curing agents one by one. The first one is multifunctional and 4 functional resin based on a DDM. We have 7 grades, variations of viscosities are there. It ranges from 3000 to up to 19,000. So viscosity is important in processing of composites. Lower the viscosity will be better for wettability of the fiber. But there are certain applications where high viscosity is also important. So we have all the variations available. And the main USP of this system based on DDM is good mechanical properties and high radiation resistance. At the same time, it offers excellent thermal stability. As we can see, glass transition temperature is more than 250 to 260. So it is used in aerospace and other tooling systems. It is already being used. The next one is aminophenol based epoxy resins. As we can see in the previous slide, these viscosities are though lower but still higher for processing. Aminophenol based product offers lower viscosity. It's up only 2000 to 7000 only. But we also have distilled resins available, so viscosity will further cut by more than, we can say 70-80%. And the other properties remaining the same, like good mechanical properties, fast reactivity, high hot wet strength. High hot wet strength is required in aerospace and aircrafts. And this is used in a casting and tooling system as well. The next one is triphenol-based multifunctional resin, that is trihydroxyphenyl methane-based resin. The best advantage is high thermal stability. It can go up to 310 degrees centigrade. It has excellent modulus when made the composite, and also having the highest chemical resistance. So this is already being used in making missile part in India. The next class of resin or self-curing resin is benzoxazine. This can be, this is self-curing, or you can use it along with the epoxy resin. And the best property that can be achieved is low coefficient of thermal expansion and the low shrinkage of the material, and also inherently flame resistant. So this is the advantage of this product. As we know, behind every successful man there is woman. So similarly, behind every successful system there is hand of curing agent. Resin alone cannot do anything. So these are the class of few curing agent manufactured by Atul Limited, but not limited only for part. There are other high performance curing agent as well. So the first one and foremost is DDS. This is used in aerospace, and this comes in a powder form. We also have micronized powder of this DDS, and there is a variation of 4,4 DDS is a 3,3 DDS, which is lower in reactivity but giving the similar properties. So along with multifunctional resin, if you use this hardeners, you get better properties and high thermal stability. The next one is DDM, diaminodiphenyl methane. This is very fast reactive, so fast productivity can be achieved and excellent chemical resistance is offered, but this comes in a pastille form. So to get advantage in a processing, we can also have the variable having a liquid system, liquid DDM. This is H667. So these are the few products which can be projected for the defense industry. There are few formulated products as well, as I already told you. These are designed to use along with pre-preg manufacturing or infusion and RTM and filament winding. We cannot discuss each and every system, but for each processing technique we have variable of high TG and low to high viscosity and variables of port life. So these are the system for infusion system and hand molding. This is for filament winding, where variables are like hot cure systems, even ambient cure systems. And these are few formulated system, high strength structural adhesives, and expandable epoxy for certain electronic applications, and to field flexible cable joint adhesives are also there, which is already used in a industry. So where all this resin and hardener together are used in industry, and it is already available in Indian defense, where it is used for missile canister and radome manufacturing, core cylinders and insulating tubings. For satellite components, we are associated with most of the government agencies, research agency as well as manufacturing. These are the few customers, proud customers that we are associated with. And I'll end my presentation with a few USPs that Atul offers. We are the trusted partner in industry, and our presence is from 1960. So the epoxy in India was introduced by Atul only, and we have a wide and deep product portfolio. If you require epoxy for any applications, we have all the formulations and all the chemistries that we have. And the best part is technical and manufacturing capability. So we have world-class state-of-the-art R&D center, which is approved by NABL, then made in India specialty for indigenous prepregs, then approval at defense organizations, and major market share in sulfone globally. And I'll give some glimpse of our Atul. So it was as a Lalbhai Group commenced manufacturing activity in 1896. And the Atul was founded in 1947. The major interest of company is in chemical, textile, engineering and agriculture. Over 7,000 employees of different nationalities are working in Atul. Our presence is in global, and we have stock points as well as offices across the globe. And companies operating through 7 divisions, where what we were talking about was in a polymer division. The other divisions are like pharma intermediates, flora, crop protection, colors and aromatic. And to give some flavor to polymer business, it was first epoxy plant in India, commenced in 1968. It was joint venture with Siba Gaigi, who invented the epoxy, and complete range of building blocks that we already explained right now, and largest manufacturer of 4,4 DDS, which is used in aerospace. So, did you know that humans' brain capacity is unlimited? But did you also know that we forget or we are likely to remember only 25% of presentation after 24 hours? So in case you need our help after 24 hours, these are the contact details. You can contact any of the team member. They will be happy to help you. Thank you. Should I remove this?
Thank you for making it sustainable. And I'm before the mementos, the menu is good today. Butter chicken, cashew nut pulao, Murthy, but butter chicken for you, huh? And butterscotch ice cream. So the army doesn't move unless the stomachs are full. So I know we are already late, almost 1 hour late for the lunch. The menu is thanks to Prashant. Huh? He is going to feed us good. And the evening tea also, cookies and nice biscuits. And we have an important session that is going to be very important for vendor development. So please bear with us. We are already short over the time. We will try to make it crisp. It's 5 minutes to 2. We will first have the small memento. Please bear with us for the formalities, and then we'll assemble back at 2 p.m. For the questions to the speakers, we have run out of time, so we would request you to please catch up during lunchtime. Can I request our speakers of this session to please come on the stage? Yeah. This is mine. I have great pleasure in presenting a memento to Mr. Hitendra Saudankar. Mr. Biswal. Mr. Ashok Kumar. And from the fine gentleman, 25% tomorrow's memory. Very nice thought, sir. Thank you.
Request Mr. Ranjiv Zadav to please come up and present a memento to Mr. Dr. Samir for chairing this session. So we'll just have a group photo. So lunch is served in the adjoining room. We'll be assembling here sharp at 2:30. Thank you.
There, Dr. Trivedi, Garda Chemicals, Mr. Abhishek Tiwari, Cortex Systems, Moldex 3D, and Captain Satyendra Vaidya. All speakers for session 2 are requested to come near dais. We'll be starting in next 5 minutes. Audience are requested to get seated. Hope you had a nice lunch. फोटोमध्ये ती डोकी दिसतात शेवटी फक्त सगळ्यांना असेंबल करता येईल हां हे पण आहेत का शेवटी हां हे डॉक्टर त्रिवेदी आहेत तेच पहिले ते पहिले आहेत नाही राधाकृष्णानंतर हां राधाकृष्णानंतर प्रेझेंटेशन आहे का त्यांना रिपीट हां आता काय करणार आहेत माहीत नाही मला परत म्हणजे जास्त होते असं ओरडे इथेच बसायला सांगतात ना हां म्हणजे हे आले म्हणजे कसं आहे की लोक जमा होतील नाहीतर अजून कोण राहिलं हां आता सगळ्यांनाच बोलवतो नंतर तुमचं प्रेझेंटेशन चालू व्हायच्या आधी मग त्यांना हवं असेल तर खाली जाऊन बसतो ज्यावेळेला प्रेझेंटेशन चालू होईल त्यावेळेला परत हां हां नाही तर मग तिथे बघायला लागेल
Requesting all the delegates to be seated, please. We are starting in another 2 minutes.
Hello, Mr. Abhishek Tiwari from Cortex Systems Limited. Can you please come on dais? Abhishek Tiwari. Cortex Systems, Abhishek Tiwari. I should start? Acha, okay. So good afternoon, everybody. We had wonderful sessions in the morning, and now we are going to start session 2, Emerging Trends and Technologies, Systems for Polymers in Defense Applications. Hope you had a wonderful lunch, and you are ready to receive new knowledge, full of new information from the dignitaries, great speakers actually. So we are starting with Dr. Radhakrishnan, opening remarks and address on defense applications. Next is Dr. Prakash Trivedi from Garda Chemicals. And after that, Mr. Abhishek Tiwari from Cortex Systems Limited, which is also known as Moldex 3D. And next topic is from the Captain Satyendra Vaidya, retired, who is an Indian Navy veteran. So these are the speakers for the next session. And I would request Dr. Radhakrishnan to start with his opening remarks and address on polymers in defense. Request rest of the speakers, please be seated, and we can call you one by one. Thank you very much.
प्रेझेंटेशन त्या MCI 2023 मध्ये फोल्डर मध्ये फोल्डर तिथं असेल हे सेशन 2 मध्ये त्यांनी कॉपी पेस्ट केलंय ना तिथं नाही हे माझं नाही माझं कॉपी पेस्ट केलं होतं ना
डिफेन्स
IPI फुल स्क्रीन कर ओके Good afternoon. We are going to start this second session just now regarding the advances in future development in polymers for defense applications. Okay, basically we talked about it in the earlier, more like what is existing, but we are now talking about some high-tech applications. In the morning I had talked about this electroactive polymers for defense. I'll just give you a brief outline of that, and then I think we'll go on to the high-tech polymers like Dr. Trivedi and others. Okay, now this is a particular area which goes directly into defense. Now, I talked about growing demands for polymers in various sectors. And then also I talked about the modern warfare, what it needs. And what it needs is smart materials, sensors, actuators, self-healing polymers, shape memory polymers, and wearable electronics. Now, as I said, conducting polymers is a very important subject for all these applications. Now, basically conducting polymers are three types: conducting polymer composites, and electroactive polymers, inherently conducting polymers, which I showed earlier, and solid polymer electrolytes, like for example, Dr. Kale said that he has solid polymer electrolytes for battery applications. These are ion conducting, whereas the first two are electronic conducting. Now what you will see that since I've been there in this field till 1985, but after this field got Nobel Prize in 2000, the number of publications and number of activities going on in this area is risen tremendously. In fact, there are 2,000 publications, almost 2,500 I will say, per year in this area. So you can imagine how much activity is going on and how important this particular area has become for both electronics and other applications. Okay. Now, conducting polymer composites is basically you put metal or any conducting particle in regular insulating matrix, and then it is conducting. That is the age-old theory. But what happens is there is what is known as a percolation. So there is a composition at which the critical concentration, the conductivity shoots up from 10 raised to minus 10 to 10 raised to plus 4. So that is where the percolation threshold, it's in logarithmic scale. So it increases tremendously. And that is why it is called percolation threshold. Now you will see that percolation threshold for normal particles, big particles, is something like 20%, 15%. Some of the carbon blacks you have to load to something like 25% to get sufficient conductivity. Whereas if you go to nanoparticles or hybrids, like for example here we have put graphite, you will see that 15% is needed to achieve some level of conductivity. Remember, it is 10 raised to minus 12, which is insulating, and then shoots to 10 raised to plus or 10 raised to minus 1. So when you add 15%, but if you go to hybrid, that whole composition comes down to something like 1%. So just 1% of that additive increases the conductivity 10 folds. So that is a great advantage of having hybrids. And this is why I was saying that hybrid composites will be very useful for radar absorption and for conducting coatings which are going on to the plane. Now, if you see here in a hybrid composite, the percolation threshold has come down in some cases to 0.2% weight. 0.2% weight, okay. So you are hardly adding percentage-wise, so that the original properties do not change. The viscosity and processability remain the same. And that's the great advantage in having this type of material. Now, conductivity chart, I don't have to show that. Polymers are insulating, metals are conducting, and these are in between. So the extended pi conjugation system is something like this, that you have all kinds of molecules with double bonds which alternate one after the other, and you have an extended pi conjugation which gives them a semiconducting nature. And all types of polymers are available, and the more aromatic they are, the more stable they are. So that's why you have polyaniline and polyphenylene sulfide and polythiophenes, and all these are pretty stable and conducting. Now, this I showed you that there are huge lot of applications. Now, bulk application is EMI RF shielding and radar shielding and anti-static component mainly, and also battery application. These are the ones which will be directly applicable to defense. Special applications like color changing and things like that. One special application which I would like to point out here is actuators. Now, this is something like an artificial muscle. You have muscle, so you actuate it. Something like that you make out of artificial polymer. So we have actuators made out of this. Now, this I explained to you. So let us go further. Now, what we have done is a EMI shielding using conducting polyaniline instead of carbon fibers. And we have doped this fibers, normal fibers, with polyaniline or conducting coating and loaded them into PE and PP. And you will see that there is a huge shielding, EMI shielding, as well as radar absorption. Now, when we say EMI shielding or radar absorption, it is in microwave frequency. And so you will see that we have a special unit which we use for testing how much is the microwave passing through, and we calculate what is the dB level of cutting off the signal. So here we will see that as you increase the polyaniline concentration into this composite, there are no signals available afterwards. So it is almost going to something like 40 dB. 40 dB means something like 99% of signal is being cut off, at least 90%. So we have something like, we have fibers which have been coated. Here, for example, we have coated PET fibers with conducting polymers, and then we incorporated these into the matrix and then check for EMI shielding. Here also you will see that after incorporation, depending upon how much is the weight percent, you will see the signals are getting cut off. And so finally at one stage, there are practically no signals available. So when it is all little noisy because originally there is some kind of shielding, and originally there is not so much microwave signal available because of the source. But even then, you can see the changes, and this is according to ASTM standard, which is quite okay. Now, there is also frequency-dependent conductivity, which helps this, because as you increase the frequency towards microwave region, the conductivity of conducting polymer composites increases tremendously, which helps to shield all the other signals. And so you have EMI shielding more effective. So you will see that that depends also on thickness, also on composition, and so on. And this is another peculiarity, that with respect to frequency, there is a particular area where it doesn't absorb. So that is where we have to concentrate if it is working in that region. So we have to incorporate higher conductivity in that region. So we can do that with respect to magnetic fillers or with respect to dielectric. Both are involved in cutting off the microwave. So we have done all that exercise, and then we have come out with EMI shielding material. Okay. So we have seen the dielectric loss factor as well as magnetic properties contribute to EMI shielding. This I showed you in the morning, but what I would like to show here is that that was in a visible range, the color change. Now we are talking about infrared detection and infrared imaging. All the military applications, there's a lot of infrared detection and imaging. So how can you hide from that? And so we have to create a camouflage, in which case we have infrared electrochromism, where you apply potential and then it becomes different color. In fact, even the temperature changes, so you become invisible to infrared. Here, for example, the temperature can go down to minus 15 degrees if you apply potential, or minus, so you don't see, the infrared doesn't see it. Infrared sees only the heat portion, okay? So we have different applications for this. So we will say that, yeah, we have an infrared camouflage. Now I'm going to talk to you about sensors and actuators. The sensors we have developed in NCL for all kinds of gases and all types of vapors, toxic, carbon monoxide, chlorine, NOx, HCl, so on. We have also developed piezo sensors, which are extremely sensitive, which are sensitive to touch sensing. Okay. Now, why we are talking about this vapor detection is that if you have, for example, explosive, depending upon what type of explosive, you have some molecules coming out of it. Now, the level of molecules which come out depends upon what type of explosive it is. But if you go to RDX, for example, you go to something like parts per trillion. So the molecules actually are seen very, very small in air because of the vapor pressure which the molecules have. So you want to detect whether there is an explosive there or not. For example, bomb detection or sniffing, you have to create a sensor which will operate at parts per trillion. So there is a different technique for this using conducting polymers. What we do is look at the fluorescence coming out of the conducting polymers. In fact, many polymeric LEDs are based on similar principles. So, but then you get a fluorescence, okay, and that fluorescence gets quenched because it absorbs this, let's say RDX molecule or any other explosive molecule, and so there will be no fluorescence. So you will see fluorescence quenching, and that is what we use at that level. Now, normal fluorescence is that you there is an emission of light which is coming out of, I won't go to technical details of this. There is a conduction band, a valency band, and then the excitation, and the fluorescence goes coming out as the radiation. But if there is something which is absorbed like TNT or RDX or something which creates in between a state, then the fluorescence cannot take place, so it is quenched. So here you will see that the quenching of fluorescence with few ppt of explosive. So there is a explanation for that, that it is, there is inside it gets multiplied like your one molecule creates another, and then you create multiplication. How can just one molecule create so much effect? So that is the explanation there. So I will not go into that. Now, as far as the piezo sensor is concerned, normal piezo sensors are based on PVDF, polyvinylidene fluoride. Now, that is a very difficult thing to make because you have to have biaxial orientation, poling, and so on. But it will give you piezo sensitivity, but the whole process of making that piezo sensor only out of PVDF is very expensive. So what we did was put some conducting polymer composite system which is piezo sensitive. And that is what we have done here, for example, using conducting polyaniline and some barium titanate and so on. And so we have a piezo sensor which is extremely sensitive at 40 gram load. 40 gram load is less than touch, okay? So you will see that it becomes a very sensitive material for piezo deformation. Now there is another thing which is extremely important, which I was talking to you about, is a coating. Corrosion resistance coating is very important for aircrafts and naval applications. And so if there are various types of coatings which are given on the aircraft, various layers, but corrosion resistant layer is the most important, so that we will be able to use that aircraft for much longer time. Navy, it is routine process to keep on painting. But if you have a corrosion resistant material, which as I showed you in the morning, that in spite of scratch, it stays, then it will be useful. So these are the new alternative materials which we have made. And so we have made conducting polyaniline nanotubes and conducting polymer hybrid coatings, and which have shown excellent results. These are the Tafel plots. We track it with respect to time over a period of days, in fact. And so you will see that it is going on shifting towards the anodic side, which means that it is becoming less and less corroding. Okay. So that is what we have done, polyaniline with TiO2, polyaniline with other things, hybrid coatings. And so what we have done is scratch the film and then tested it. Okay. And then you will see that there is nothing happening on the scratch. So that's the great advantage here. So what we have is a conducting coating which is corrosion resistant as well as EMI shielding. Now coming to actuators, what do you mean by actuators? When you have a material which is with the input signal, it gives you output response. It can be contraction, expansion, bending, or whatever have you. So whenever you see actuation, you will see that the shape of the material changes. The reverse process is piezo, that when you apply pressure, it gives out signal. So here what we are seeing is the actual bending of conducting polymer with application of voltage. And then we have actually worked on this. It looks like a cantilever beam with certain modulus, and we optimize the whole thing so that we get a maximum bending at minimum voltage. And where are the applications? Robotics, remote control systems, smart systems, process valves. And when you say robotics, it's all actuation, okay? So if you are having soft actuation also, it is very useful for you. Then this I showed in the morning, that you have physiological movement when you apply conducting polymers. Okay. So simultaneous corrosion protection and radar shielding can be achieved by a single coating if you use conducting hybrid composite. Okay. And I like to thank all the students who worked on this. Okay. Thank you. Now these are the high-tech applications we are going to discuss, something like this, with, which are needed by the defense sector. And so I invite Dr. Trivedi first for his talk to the dais. He is going to talk to you on very high temperature polymers which he has made. And also I think some part which he has worked with Amrita Institute of Technology.
So meanwhile, I will introduce Dr. Prakash Trivedi. So thank you, Dr. Radhakrishnan. We have actually two dignitaries who are the Lifetime Achievement Awardee from IPI, Dr. Radhakrishnan and now Dr. Prakash Trivedi. Dr. Prakash Trivedi is a MSc in Polymer Chemistry from UDCT and a PhD in Polymer Science from Akron University. Actually, he has written one wonderful book on high performance polymers, which is one of my favorite book. So he is actually, truly he has done wonderful developments on Atmanirbharta, the high performance polymers like a PI, PEG, and PEEK, PBI, etc. So he is a distinguished alumnus awardee from the UDCT and adjunct professor in ICT since 2019. And having a 25 international patents and 90 publications and presentations in national and international journals. So I request Dr. Trivedi to start his session. Thank you very much.
IPI Yes. Okay. Thank you. Namaste. I'm happy to be here. Thanks to IPI and MCCIA. It's a really pleasure. The seminar has been excellent. I'm very happy that we have been able to do this. And I'm going to divide my talk in two parts. One is where I'm going to talk first about the polymers we have developed. And the second part is where the composites we have developed, which are having some fairly good, I would say, possibilities in defense, both in Navy and Army to begin with, and hopefully in Air Force too. This lights are very sharp, and I'm now Shah Rukh Khan, but they told me that that way you don't know who is going to doze off in the audience. So fine, no problem. This high-performance polymers, we have been working in Gada Chemicals for last about 12 years, 11, 12 years. And it's still going on. It takes time. You have seen in the earlier presentation by my colleagues here that there is a what we call thermoplastic pyramid. And we work at the highest level of thermoplastic polymer with polytherketone, ketone, polybenzimidazole. And now to make it a little more, what should I say, commercially viable, we are starting with polytheramide by end of this year. As you can see, these four polymers, we are second in the world, maybe third if you take PKK, but I think Solvay has stopped making it, if I'm not wrong. We make powders, we make granules, we make reinforced materials, mineral filled, glass filled, carbon fiber filled, even multi-wall carbon nanotube filled, which is only a tiny amount anyway, 2, 3, 4%. We also make blends and alloys. And the most interesting thing is that we make fiber. This polybenzimidazole is such a beast, as you will see in my next slide. Before I come to that, you can see that these polymers are, the TG is maybe 160, 170, not very high, but they are all crystalline polymer. And the highest one, what we call 100 has a TM of about 395 degrees C. In the literature, it used to say that you can't process this because it's a very high temperature and polymers tend to degrade at 420 degrees C when you try to process it. But we have managed to make very strong, very, what should I say, stable polymer that can withstand that kind of temperature and shear rate that you need to process it. And we even make 20-30% carbon fiber field, which increases the viscosity anyway. So all these things are possible. The question is, these are the solutions waiting for the problems to come forward so we can solve it. Yeah? The PK is also part of polytherketone family, but the polybenzimidazole is a real beast because it is TG that is 485 degrees C, not TM, TG. So you can imagine that it cannot, and it took us a long time to understand how to say whether it is amorphous or crystalline. Finally, and luckily we had X-ray machine, diffraction machine, so we could see those diffraction patterns and we knew that, yeah, it is a crystalline material, which is great. But how do you process? The theoretical TM is about 650, 670 degrees C. You can't process that material. But we found a way out, kind of circumvented that problem, and we used that. We also have a, I'm not going to talk about it, but sulfonated PKK, which can be used for high temperature fuel cell applications, or for as an adhesive promoter for carbon fiber with any of the polymers that you want to use. Okay, these are some of the things that we are doing like any other normal resin manufacturer. So let me not go too much into it. Then, oh, sorry. Okay. These polymers, as you can see, that about 250 degrees C, they still can have very high tensile strength. And yeah, it's a tensile strength. You can have flex strength also. The tensile strength of this polymer at 250 degrees C is equivalent to what tensile strength you have for polypropylene or ABS at room temperature. You can see the difference in this commodity plastic versus specialty plastics. Even engineering plastic like polycarbonate, etc., don't have this type of strength. There was a nice slide earlier showed on specific flexural modulus. And you can see here that with PKK with 30% carbon fiber or PK with 40% carbon fiber, they are having almost as good specific strength as aluminum and almost approaching that of steel. So what is specific strength? It means that strength divided by its specific gravity. So what is steel, for example, is about 7 specific gravity, and these are all about 1.4, 1.6 type of specific gravity. Okay. So now what do we do with this? We can make this type of large size rods or plates. We don't make plates, but we certainly make rods. And people buy this and then cut it and machine it into gears, seals, etc. And they have, as you can imagine, they can be used continuously for years at about 260, 240 degrees C for a very long time. The continuous use temperature was defined as when the specific strength comes down, or rather tensile strength comes down to 50% after 12 years of exposing this material to that temperature. Okay? We can make this type of pre-packs, PKK with carbon fiber, which can then be converted into different shapes and articles, and then you can bake that. Some of these things are now going or beginning to start going for aerospace applications. So I'll be very happy if I can work with HIL or other people. This is an interesting slide. On the left is a skull. So PKK has a very tremendously interesting possibility where it tends to, what should I say, the bone cells grow over it. If you use PTFE, PTFE is fantastic too. It doesn't have any chemical effect of any chemicals, I mean. But the bone cells tend to wither away. While with PKK, it grows over it. So they are using it for skull. And what is shown here is a material where PKK is used. The surgeon sends the file to this company, our customer in US, and they then laser print this, 3D printing by laser technique to the shape that they have sent, and then you can, within a week, you can get a new skull on your head. The one on the right side are the small implants for the spine. And the one which are in the bottom, let me show you this also. These are the aerospace applications. Now you can see that this can be made very easily using 3D printing. Now days are slowly going when you are wanting to make some specialized design. You have to use 3D printing. You can't use normal injection molding or even extrusion with machining and all that. You can't make this material with machining. Yes, you have to make several different type of parts and then join them somehow by ultrasonic or whatever way you have, solvent or whatever technique you want to use. It's very cumbersome. While with 3D printing, you can get it really nicely done. And these are some of the parts. I think other people have given better knowledge about what polymer can do for aerospace, so I'll not get into this. But the potential is used. Unfortunately, what happened when our PVKK plant started in about end of 2019, and then the pandemic came, 2-3 major accidents happened with Boeing. We are working very closely with Boeing, and everything went down. So now we have to restart. Things are now beginning to look back. The polybenzimidazole, as I said, it is so high in temperature in terms of processing requirement that you cannot use it otherwise. So what we did is, and luckily that was possible, because we made it in a solvent, very highly acidic solvent. So when you make it in a solvent, of course you have to get rid of solvent. And when you try to get rid of solvent, depending upon how you precipitate or how you get rid of that solvent, you can get powder, or you can get film, or you can get fiber. And that is what you can see here. The gloves that you see on the left side or your right side, the black portion, black colored part is our polybenzimidazole, and the white is Kevlar. One more thing, we have worked with DRDO New Delhi, and we have been able to successfully make this fireman's suit. Today what is happening is that we are importing fireman's suits, or we are importing clothes and then maybe weaving it here. But we are hoping that someday we can do this ourselves. Now this would be not only good for firemen's, but it would be good for oil and gas industries, with army where the fire hazard is there, navy or particularly submarines, etc. And I'll show you something, what happens when we put a match towards it. So we have made several now composites, and maybe this slide should have come later on, but with Professor Bhaumik and his students at Amruta Vishwavidyapit in Coimbatore. You know, now the latest saying is that we have to work with triple helix. We know RNA has single helix, DNA has 2 helix. We have to work with triple helix. What does it mean? The triple helix means that you have to have industry, you have to have an academic institution, and of course government. So what I am going to say now is we work as an industry with this Amruta Vishwavidyapit, and then we worked with army, and we made some very interesting composites that I would like to show you. These are typical composites, 5 or 7 layer composites with polyether ketone film that we prepare in our lab, and polybenzimidazole fibers, which also we prepare in the lab. And here how it looks when afterwards we compression mold the whole thing. Now see the interesting part. You can put it on a Bunsen burner, which is what, about 650, 700, maybe slightly more. It doesn't burn. It just sits there, looks at you. There is no smoke even. And you know, the major fire hazard is not fire so much as the smoke that is generated. Lot of smoke, and if it is toxic, it is worst. The other hazard is that if it starts dripping, you know, and then you have a carpet like that, and the carpet will catch fire. This doesn't drip even. Even more interestingly, that we put some fuel, diesel, over that material, that composite. No, I mean, I can't keep diesel from burning, obviously. So it is burning, But afterwards, you can see that it is not much affected. It has remained more or less as it was before. And we have taken now trial with this. We have made, I don't have unfortunately slides because they are not released yet by our third strand of the helix, triple helix. But we have taken trial in Himalayan region where the temperature was minus 25 and with wind blowing it was minus 30, minus 35. It showed no problem in terms of impact. It could be very good impact resistance. It doesn't burn, as I showed you. Even there we took trial, it didn't burn. And so we had suggested that, okay, why not we make cabins out of it? There have been some instances where cabins have been made for our fighters, Jawans to stay. But they are not necessarily fire resistant. Well, here you have something which is fire resistant. Other thing is that those temperature outside is minus 30. Temperature inside that cabin is about 15, 17 degrees. So something that we are hoping we can get everybody excited. Now here is something I am looking for volunteers if anybody wants to raise the hand. This is a bulletproof composite, and this is a bulletproof composite on which AK-47 bullets have been fired. It didn't go through. It didn't go through. But I have not, I must say, Samir, I have not got any volunteer to stand with this. But this is, again, very interesting thing. The beautiful part of all these composites are that at least, well, first one, 100% made in India, not composite, but even the material going for composite. This one is about 65% made in India, and the fiber, which we are not making so far, we hope to make it maybe in next 1 year in Garda Chemicals. So that is the beauty of this development. Here is a very interesting blast-proof composite. So this composite can go, and that actual trial has to be taken, and it will be taken in Pune, interestingly. But we have taken trials by keeping the composite and blasting some TNT below it, 100 kg or something like that. And you can see that it didn't do any damage. So these are the three composites. And this is again, it's a carbon fiber PEK ceramic composite, and that is I think aluminum hexagon type of structure in between. Again, mainly made in India. Carbon fiber is not made in India yet. Some people tried, but has not gone. So that has to be imported, but otherwise it is made in India. These are some of the applications for the industry. I'd like to thank my colleagues in industry, in academia with whom I have worked closely. Garda Chemicals has got about 12 national awards for doing this type of work. The one which is given in black were the one we took a long time back, before 2005, 2006. After that, Garda decided to sell that whole technology of polysulfone, etc., to Solvay, so it is part of Solvay. And we had to restart it again in 2012, 11, 12. And so the red thing is where we got it in the more recent time. With that, I'd like to thank you very much again, and thank you. It's 20 minutes, including introduction.
So, thank you, Dr. Trivedi, for your wonderful session on polymeric beast. I like that word very much. And this session was a very, really technical feast. So, great. Thank you, Dr. Trivedi. So we have seen since morning various polymer materials, polymer applications, but please hold. Are you directly going to put them in the mold and conduct molding or line trials? Please hold. There is some technology which can help you to simulate those polymers, how they are going to behave in the mold, how they are going to perform in the actual injection molding process, whether there will be any issues during molding. And there is a technology called as a Moldex. And to represent that technology, Mr. Abhishek Tiwari is there. He's from Cortex Systems. He is having 15 years of experience and his master's in CAD and from CPET, Tool Design, Hyderabad. He is a certified professional from Moldex 3D, Taiwan, and scientific injection molding practitioner from UK, G&A Molding. So currently he's a regional manager from Moldex 3D, and he manages Western and North region of India. So he's having a large experience in 3D simulation of plastics injection molding and similar process. So let us listen from him how he can help us in developing these applications with real actual simulations. Mr. Abhishek Tiwari, please come.
Good afternoon, everyone. Good afternoon, everyone. Thank you for having me here. First of all, I will share my feelings that I'm really privileged to share the dais with Dr. Radhakrishnan sir and Trivedi sir, and from whom we have learned many things in industry. So I am going to speak about the emerging trend in defense application. Mostly we know whenever we talk about injection molding, we talk about the normal injection molding which is used in automotive industries or electronic industries. But here I'm going to talk about the applications which are used in different industries. So this is the outline of my session. So first I'll start with the Moldex 3D introduction, who we are, from where we are, and then we will talk about the trend of powder injection molding in manufacturing of precision parts used for making the arms. Apart from that, we will also talk about the growing trend of lightweighting of composite materials for aerospace industries. Apart from this, after doing the simulation, how to integrate the simulation with the structural simulation softwares, we are going to discuss about that. We will summarize the session, and then for Q&A session, we have the booth, so you can join us over there. So starting with Moldex 3D introduction. So basically, the theory foundation of Moldex 3D happened in Taiwan University by Dr. R.Y. Chang, who was the founder of Moldex 3D. He was the first person to introduce the 3D meshing technology for the flow simulation application. Later on, we became as a brand in 1995 as Moldex 3D, and we started catering the global market. We have multiple strategic alliances with major CAD players and major FEA softwares like PTC, Siemens, Dassault Systems, Cimatron, ANSYS, Abacus, MSc Nastran, and many more. And that is why we have been awarded by multiple innovation awards, and we are continuously improving our technology to cater the simulation world. We have our offices, overall total 12 direct offices we have. Our headquarter is in Taiwan, Hsinchu, and in India, our headquarter is in Chennai, IIT Madras campus. So what we do? Basically, whenever the product designer designs a product and then send it for the manufacturing, if there is any product design issues or if there is any tool design issue which is not captured at the early stage, and then we go for the trial. At that time, if we find what's going wrong, or we get a sudden surprise that the dimensions are not matching, or we have a serious molding defect, then in that case, the whole project goes for a toss. That's the reason Moldix 3D plays a role as a leading validation tool, which will help you validate your product design and tool design and the process which you are going to use for manufacturing that particular process. That's the reason we have been awarded multiple times. So here you can see we have been awarded by International Polymer Awards by James White. We have been awarded by Taiwan government for Taiwan Excellency Award for creating the component which is catering the global market, Taiwan made in Taiwan component. Then we have been awarded by Japanese award, that is Aiko Takashi Innovation Award. And apart from that, we got an privilege to participate in US Energy Department research, wherein we were the partner to develop the lightweighting material. Apart from that, we have the material testing center in Taiwan, which is ISO certified, and wherein we test all the different types of plastic materials, composite materials, and PI materials. So with the non-stop innovation technology, every year Moldix 3D is adding more and more capabilities and more new features. Like from 2010, we have the powder injection molding and the composite process, which you can simulate in Moldix 3D. So in industry, across the globe, we have 8,000 plus companies already using Moldix 3D. So all the major automotive manufacturers, whether it is Nissan, Yamaha, Ford, Toyota, Mazda, already using Moldix 3D. When it comes to high-tech electronic companies like Sony, Panasonic, Logitech, already using Moldix 3D. Material equipment manufacturers and material manufacturers like BSF, DSM, Sabic are already using Moldix 3D, and also hot runner manufacturers like Moldmasters, Udo, Husky, Inventive are using Moldix 3D. We also have semiconductor IC packaging technology. However, today I'm not going to speak about these technology. I'm going to focus on the two important part. So if you see the market share, we have also a sector known as composites and the special process. So we are going to discuss about that. So the first process which I'm going to discuss is the trend of powder injection molding in manufacturing of the plastic parts for arms. Now when we see the precision components required for manufacturing the arms like gun, here earlier to make such critical precision parts, the technology used was maybe the investment casting or high pressure casting. After that, secondary operations were required so as to ensure the required tolerance and position tolerance, because you can see these components are very critical in terms of tolerance and size. So you can see the picture of a titanium gun trigger, and you can also see the pistol upswept grip, which is very critical. The position tolerance is very important. Also, there are many tiny gears, and you can see the military safe and arm rotor. So these components are very critical, and the tolerance is required. So that's the reason powder injection molding technology, which helps to utilize the benefit of injection molding technology and the precision and repeatability of injection molding technology. So here, this particular technology of powder injection molding was first introduced by NASA in 1973, wherein they came up with this technology of powder metallurgy mixed with the benefit of injection molding and precision of injection molding. So the overall process is the material in the form of the steel or the metal material in the form of powder is mixed with a plastic binder, and it develops a feedstock. This feedstock is now used like a polymer, how we do the normal plastic injection molding. The same way, the mixture of this metal and this plastic is mixed, and it is sent to the injection molding machine, and then the green part is produced with the help of this feedstock. Now, this green part is a combination of plastic and the metal. Later on, there is a secondary process that is called debinding. So this debinding can be done by the solvent-based process or by the debinding furnace. And then finally, these parts are later on sintered with the help of furnace, to sinter it, to the final part. So now, here, this is the whole process. Here you can see that first we see that there is the two material, which is mixed and the feedstock is ready. Now you can see at the center side, you will see that these are the three processes. Feedstock testing, so Moldix 3D provides you the services for the testing of the feedstock so that we can understand what are the properties of that feedstock, how that particular material will flow inside the mold, okay? So that we can understand how the material will flow, where exactly the weld line will be, where will be the weaker cross sections, and we can judge the product quality. Then after that, the whole injection molding process can be simulated in Moldix 3D. And finally, the green part, what will be the quality of green part, whether there will be any black lines or where there will be any powder separation, that kind of issues we can capture. Later on, the green part is sintered, and then finally we get the part. So on the right hand side, you can see the green part is the mixture of polymer and the metal powders. Okay. Later on, during the debinding phase, the polymer is drained out or it is burned out, and then you see you have a brittle brown part, which is nothing but it is a brittle part with only metal molecules. Later on, these metal molecules are sent to the sintering furnace, wherein the molecules form necking procedure initially, and after that, they come up with the final sintered part. So this is a very critical technology. However, with this particular technology, many challenges are also present. For example, one of the biggest challenge this industry is facing is about the phase separation. Now we know that the injection molding process is very good in terms of repeatability, in terms of precision. However, the injection molding process itself also adds to shear. When the material gets to shear, at that time, when you see the molecular flow of the material, at the surface area and at the core area, you see the different shear pattern. And this could add to a problem, very critical problem, that is called phase separation. That means when you make a particular component like gear, maybe on the 10th teeth of gear, you have high metal concentration, and on 10th teeth of gear, you have low metal concentration. So when you sinter it, after sintering, you will see that the three gear teeths are gone, because there is no metal part over there. So these kind of parts will make a rejection. So that's the reason Moldix 3D software helps you simulate the analysis. So here, with the help of Moldix 3D analysis, we can run the simulation and understand what is the flow pattern. With the particle tracer technology, we can understand whether the particle has reached to each and every small tiny corners, whether you have a good powder concentration or not. And then finally, how the part is going to deform and what dimensional accuracy you are going to get. So this is how the flow simulation software helps you understand the quality of the green part so that you get a good sintered part. Now, this is being widely used, and this is an upcoming trend which is now majorly used for precision component in the defense application. Now the next technology I'm going to talk, which since morning many people have already spoken on it. So you can see that the trend of lightweighting through composite materials. I still recall in the morning session, Dr. Ramakrishnan sir already highlighted that in Tejas, 45% of the material weight is composite, and almost 90% of the surface area is composite materials. So the trend of lightweighting and composite material cannot be denied, and it is widely used in the aircraft industries now. So here I am just showing you a matrix that depending on the type of material, whether it is reinforced plastic in the form of short fiber, long fiber, in the form of chopped fiber, or in the form of fabric. Depending on what type of configuration of fibers or fillers in the composite you have, the technology is being selected. So irrespective of that, in Moldix 3D, we can simulate all the different type of process which are required for the composite materials. So for example, if it is a short granule fiber, then in that case, we can simulate it with the injection molding process. If it is a glass molding compound or glass GMT technology, then with the help of compression molding technology, we can simulate and we can understand how the fiber is distributed across the geometry. Apart from that, direct long fiber thermoplastic is also used. So LFT material is also used widely in industry, and SMC material is also used for composite manufacturing. Apart from this, resin transfer molding, especially the vacuum-assisted resin transfer molding, is widely used in industry for creating the lightweight composite materials. And here you can see an example of a wind turbine blade, which requires a very lightweight but still a very good structural strength. So here, with the help of Moldix 3D, we can simulate the overall procedure with the vacuum assistance, and we can understand what type of flow pattern we are going to get, where exactly we are going to get the air traps and voids, and predict the failure before designing the or before manufacturing the component. The RTM process, further we also support in Moldix 3D wet RTM, which is a combination of resin transfer molding with compression. So here you can see that you have a resin, then an inlet location from where the material will come, and then the fabric. This fabric will be laid out based on what type of fiber orientation you have on the fabric. The flow pattern of that particular polymer will be dependent. So we also have to provide the moving condition for the moving surface. So we can also simulate the wet resin transfer molding. Now here, in the wet resin transfer molding, it is very, very important to understand the effect of the ply layup orientation. So here you can see we are talking about two different types of layup. Layup 1, you have the fiber orientation on the left side, and layup 2, we have the fiber orientation inclined toward the right side. So depending on what type of fiber layout you have on your fiber, how the flow pattern will change of that material, you can see, and based on that, which particular location we will be having the voids, which particular location we will be having the air traps, we can judge very accurately before we manufacture the process or the mold. So this is very, very helpful for the designers or the scientists to understand what type of layer and what type of fiber orientation is required, whether it should be bidirectional or unidirectional fiber orientation, and how it is going to impact the results and the flow pattern. Apart from this, we know that drones are widely used in defense application now, and these drones should be lightweighted, and we know that it should have a good it is having a good complicated geometry. So many times we have to make a process which is a kind of hybrid process, wherein we do the overmolding of the plastic over these composite materials. So even Moldix 3D can simulate the overmolding procedure of the composites, and we can understand how the overmolding procedure is going to have impact. That means how the injection of the second shot is going to impact the existing material over there, whether that particular material will bend, whether that particular material will have deformation or it will remelt. We can check this technology and we can design the process accordingly. So now when we are talking about the overall simulation part, one very, very important factor which is very, very important for simulation accuracy is the material testing. We know that every day new composite materials with different compounds, different compositions are coming. So Moldix 3D also caters the service for testing the material. So in Taiwan, we have material testing center wherein we can test n number of different grades of thermoplastic materials, thermoset materials, rubber, powder injection molding feedstocks, and composite materials like GMT grades, SMC grades, BMC grades, and resin transfer mats for checking the porosity and permeability. So these kind of testing facilities are also available in Moldix 3D. Now, after we do the simulation and we understand that how the material will perform, one more thing comes into picture, that maybe we design a particular component, we do the analysis, and we have a result. But how my particular component is going to have the structural strength, how to judge that at the early stage? So here, Moldix 3D knows the importance of this, that we have to check the sustainability test, we have to check the performance, structural performance of the component. So for that, Moldix 3D has a very good integration with all the major FEA softwares, whether it is ANSYS, Abacus, Nastran, MSC, or OptiStruct. We have a very good integration. Now, what does this particular feature helps? Basically, when you capture the defect after the flow simulation, you capture that my particular component is having a weak fiber orientation, a poor fiber orientation in one particular location, and a poor weld line in particular location. How much strength that particular weaker section will have, if I want to cross-check, I need to pass on those information from Moldix 3D to the structural simulation software. So this FEA interface basically works as a bridge between the Moldix 3D software, the CAE software for flow simulation, and the structural simulation software. So now, once your structural simulation software will know where exactly there is a weak weld line, where exactly there is a poor fiber orientation, the prediction of the structural simulation software will be more accurate and more realistic. And we do this for linear as well as non-linear. So if in case you are also using non-linear materials and you want to do the non-linear analysis, here Moldix 3D can also integrate with softwares like Digimat, Converse, and we can understand the non-linear property and the material performance of that particular material and integrate it with the simulation to ensure that we get a very accurate and reliable result from the structural simulation software. So I will quickly summarize on this particular session that mostly in industry, normally people do the systematic way, that the systematic way is first we should create the structure. What is the issue behind this structure? We figure out what is the root cause of the problem, and then we take the corrective action to overcome that particular root cause and ensure that we have a optimum design, rather than the traditional way wherein we keep on doing multiple trials, T0, T01, T2, like that, and keep on assuming what particular thing is going to improve my product quality. So that is how Moldix 3D flow simulation software helps you test your product design, tool design, and the process which you are planning to use for manufacturing that particular process, and it helps you identify the potential risk at the very early stage so that you can optimize your product design, tool design, and process, and ensure that you get the product first time right. So you can contact us on this. This is our contact details, and we also have the stall in the adjacent hall. So I will conclude my session with that. Thank you very much.
Thank you, Abhishek, for your wonderful session on Moldix products and simulation. In fact, you have taken us into colorful virtual reality of various molding process. I really appreciate that. Since morning, actually, we are seeing various materials, polymers, materials applications, and now we have entered into virtual reality. And next is the molding processes. The components are molded, components are used. And it comes to the end of life, actually, of the products and components. And we come to the very sensitive topic of current age is waste, actually, waste. That is a solid waste or whatever waste is there. And we have actually a great expert in this, in the solid waste management area, and who is going to talk about polymeric materials and solid waste management. Captain Satyendra Vaidya, who is the Director of International Council for Solid Waste Management. And for your information, he was a qualified helicopter pilot and Indian Navy veteran, over 27 years of a commissioned service. That's a great experience. And his passion is after retirement, the very important neglected area of solid waste management. He is a founding director of International Council for Waste Management, a fledgling NGO, and focusing on providing integrated solid waste management solutions and preparation of sustainability reports. Amongst notable projects he has done for Indian Defense is integrated waste management project at a military station at Udhampur, which was very well, greatly appreciated all over India. And preparation of DPR for the SWM in NDA. And also in a similar kind of military stations, he has worked on this solid waste management area. He is a qualified Lean Six Sigma Green Belt practitioner and completed global reporting initiative courses for reporting with the GRI standards. So that is also an additional feather in his cap. So I request Captain Vaidya to come on dais and enlighten us with the very important sensitive topic of solid waste management and polymers in defense. Yeah, yeah.
Well, good evening, everyone. I think I'm the biggest oddball going out here. I don't have a degree in polymers. I'm not an engineer. I don't have a manufacturing unit. And I'm still here. So thank you, IPI, for inviting me. I have a few ideas about sustainability. I'm not too sure whether this is the right part of the program that I should be talking about, because everyone's talking about advanced polymers. But I have a few points which I'll just put across from what I have gathered during the day. There was talk in the morning about, that chicken and egg problem, that we'll make it if the services buy it. But if the services are not giving us an order, we can't make it. My suggestion would be that you have to start looking at dual-use applications. Right since history, it was the military that was leading inventions, and those inventions were used into civilian applications. Times have changed. I think you need to look at dual applications for all the advanced polymers that you're using, and that would probably make a business sense. That would be more sustainable for every organization who's making it as well as who's purchasing it. There is a word of caution about manufacturing here and exporting abroad. A lot of sustainability issues are coming up. Europe is soon going to have the carbon border management mechanism, where they will look at how sustainable your company is. In fact, I was just talking to the sustainability head at MCCI, and they were mentioning that these are issues which are facing companies in future. It is not going to be different for all the, especially the smaller manufacturers of polymers. And if you want to expand your growth into various geographies, because that is the only way I think you will grow. I have my doubts whether the Indian Armed Forces in themselves will be able to give you the kind of orders that even Dr. Radhakrishnan was mentioning in the morning, that someone is manufacturing 5,000 TPD and here we've got a capability of 500 TPD. Even if you can never match their pricing. Regarding manufacturing in India, the Defense Procurement Manual 2016, I am not too sure if it's been revised, but it gives a lot of stress and the highest priority for all materials and all equipment manufactured and designed in India. So there is no doubt that if you manufacture and design it in India, you will be on top priority and you will get your foot in the door. But you have to have the I was there in the acquisition wing of Ministry of Defense, and what I noticed out there is a lot of foreign players are now coming into India, because this particular clause says that a minimum of 50% has to be designed and developed in India. So if you don't try to make the whole thing, don't try to make an Arjun battle tank or a naval warship on your own. Try to get into the spare manufacturing, because that will get you a lot of traction. The companies who come into India, you've seen Tata, Airbus have a collaboration now. Airbus has not come to India to manufacture those 76 aircraft for the Air Force. Okay, they have bigger plans. So see if you can get into the spare part manufacturing, whether it's composites or advanced polymers for these companies, because that is where you will get scale. That is where you will go international. I'm sure the Army organizes it. I am very certain that the Navy organizes. There are indigenization seminars and melas held at least twice a year. I think that is the place you all should go, because what I see here is a largely manufacturers and designers organization with a very little representation from the armed forces. So if you all go there, what the Navy does, and I'm sure the Army and the Air Force do the same thing, they have a lot of parts and equipment which they want indigenized. I will give you an example. About 6-7 years back, the Indian naval tanker was facing a problem. Some of the bearings in the main shaft used to deteriorate. They had a life of 10,000 or 20,000 hours, but then this tanker runs 24/7 for at least a few weeks at a time. These bearings used to come from Russia, and they were prohibitively expensive. When the Indian Navy asked people, in fact, the one who did it was a company from Pune itself. They developed the bearing, but they said, we can't give you 10,000 hours life. We will give you only 6,000 hours of life. But our bearing will be 1/10 the cost, so you can change it, 3 or 4 times within that 10,000 hours. And that's what happened. So they have started. So what I'm trying to get at is, don't go for the, the furthest that someone can do. I'm sure the armed forces will be willing to lower their specs, provided it is affordable. I know how the specs are designed, since like I mentioned, I was there in the Ministry of Defense. So there is a scope for reducing the specs, provided it is affordable. And of course, the supply chain is available. It cannot be that it's affordable, but the supply chain is not there. And then, of course, which I come to, like I mentioned, this is advanced polymers. So I don't know if it's the right forum to say. But whenever we talk about the armed forces, we only look at combat operations. There is a whole lot of polymers being used in non-combat operations. You all can focus on that. There is a whole lot of packaging. There are works. I mean, the armed forces also live in societies. And that is where I get to my, passionate subject, that we need to look at more recycled material also. I know all of you are, virgin polymer manufacturers, but a time has come that you all also look at recycled materials for the armed forces in non-combat roles. There is so much more that can be done on that field, and probably that will get us into that sustainability bracket, and I guess that is the way to go ahead. And if I could request the armed forces also to lay a bit more stress on checking up about the sustainability principles. It will happen. It is already there for the top 1,000 companies in the country to report on their sustainability targets. A time is not very far away from when we are procuring, in the sense that armed forces are procuring their materials. The government will say that the companies who are supplying it should show their sustainability reports. So my sincere advice to you all would be that look at this factor of sustainability. I know it is a cost in the beginning, but going forward, if you all want to compete in the international arena, like I mentioned, you start manufacturing. Tata also does parts for Boeing in their Hyderabad facility. It will be a good idea to become a supplier to Tata. HAL does work for Boeing, if I'm not wrong. So try to get onto this kind of a journey where you are manufacturing multiple small parts, and thereby you gain your research, you gain experience, and then you can go for the completely assembled equipment or some such thing. This is what I had to say. Like I mentioned, I'm not a specialist on advanced polymers or polymers for that thing, but my 2 bits on the sustainability words, you can call it a bandwagon. Everyone will have to join it sooner or later. And the earlier you all do it, I think the longer your stay in this environment is going to be. Thank you once again, IPI, for inviting me. Thank you.
Thank you, Captain Vaidya. Request all the speakers of this session to come up on the dais, please. Dr. Prakash Trivedi, Dr. Abhishek Tiwari, and Captain Satyendra Vaidya. So, sir, I request you to hand over the mementos to our speakers. Dr. Prakash Trivedi, sir. Mr. Abhishek Tiwari. And Captain Satyendra Vaidya. Thank you. We'll have a group photo, please. Sunil, if you can just stand in the front. We will continue with the next session. So we have two speakers who would basically give us an outlook about who would give an outlook about outsourcing requirements of their particular establishments and companies. So first up we have Mr. Suhas Jhende, who represents Mazgaon Dock. He's the Chief Manager, Contracts and Submarines. And he'll be speaking about what kind of opportunities are available to the industries. So I would like to request Mr. Jhende to please come up on the dais, please. There's a short film, I believe, which you'd like to show. Yeah, to start with. It's got that cap now. It's a problem because then the audio also निकाला.
पहले कॉपी कर ले. Let me start and then we will start AV. Okay.
So he'll start, he'll start and then he'll run the video. नहीं ते करतील नंतर. Okay, fine. He'll just talk with you.
Good evening, all of you. I'm Suhas Jhende. I'm representing Mazgaon Dock Shipbuilders Limited, which is one of the DPSU operating under Ministry of Defense, DDP, that's Department of Defense Production. Let me thank first management of MCCIA for inviting us and giving us an opportunity to interact with the industry. Although the topic is specific for polymers and specialty materials in defense, I would like to start with our introduction with a small AV. You will get to know what we are into, and then accordingly we can look at our requirements to start with. So I'll just in initiate. Yeah, na? This is basically our product profile, what we do.
The world is looking at India, and we are ready with commitment, with quality, with pride, with passion, and with the vision to place India on the world map of warship and submarine construction. We are Mazagon Dock Shipbuilders Limited, the premier warship and only submarine building yard in India. The journey began in 1774 with a small dry dock for repairing ships of the East India Company. And since then, passing through various ownerships, MDL finally came under Government of India in 1960 to commence indigenous production of warships for the Indian Navy, charting a new course for Indian shipbuilding. The new voyage started with the 6 Leander class frigates, built under license from the British Admiralty. The first of this class, INS Nilgiri, was commissioned in 1972. The Leanders were followed by the Godavari class frigates, the Kukri class corvettes, 1241 RE missile boats, the celebrated Delhi class destroyers, the Shivalik class stealth frigates, and the Kolkata class of stealth destroyers with anti-surface, anti-air and anti-submarine capability and equipped with the state-of-the-art weapons and sensors. MDL continues its saga of indigenous warship building with the 4 destroyers of the P-15 Bravo class. These mighty warships will have the most potent combat systems, advanced communication suits, and powerful propulsion plants sourced from all over the globe and integrated by MDL to operate from a common platform. MDL takes pride in the commissioning of first and second of its P-15 Bravo class guided missile stealth destroyers, INS Vishakhapatnam and INS Murmugao by the Indian Navy on 21 November 2021 and 18th December 2022. The 3rd destroyer, Imphal, is at an advanced stage of outfitting, and the 4th destroyer, Surat, was launched on 17th May 2022. In addition, MDL is also constructing 4 in number, highly complex P-17 Alpha class stealth frigates using integrated construction methodology. The first ship of this class, Nilgiri, was launched on 28th September 2019 and is now being outfitted. The 2nd and 3rd ships, Udaygiri and Taragiri, were launched on 17th May 2022 and 11th September 2022 respectively. The keel of 4th ship was laid on 28th June 2022. Also, they are indigenously designed by the Indian Navy's in-house organization, Directorate of Naval Design, and constructed by Mazagon Dock Shipbuilders Limited. Mazagon Dock is the only shipyard in the country to have built conventional submarines. And it is a matter of great pride for India that the 2 MDL-built SSK submarines, INS Shalki and INS Shankul, commissioned in the early 90s, are still in service today. As a natural consequence, MDL is also undertaking the medium refit and life certificate of these fine submarines to extend their availability to the nation. Presently, MDL is executing the order for building 6 Scorpion-class submarines in collaboration with Naval Group France. The commissioning of the first Scorpion, INS Kalvari, on 14th December 2017 reaffirmed India's membership in the exclusive group of submarine constructing nations.
INS कलवरी पनडुब्बी को बनाने में भारतीयों का पसीना लगा है। ये मेक इन इंडिया का एक उत्तम उदाहरण है।
MDL's contribution to national security continued with the commissioning of the second, third and fourth Scorpene, namely INS Khanderi on 28th September 2019, INS Karanj 10th March 2021 and INS Vela 25th November 2021 respectively into the Indian Navy. The fifth submarine Vagir was delivered to the Indian Navy on 20th December 2022. Whilst the sixth submarine Vakshir was launched on 20th April 2022 and presently undergoing trials. We have also built a variety of commercial and paramilitary craft. Right up to the late 90s, MDL was in the forefront of fabricating offshore structures. Till this line of business was eased off to cater for growing defense projects. The last commercial vessels built by MDL were two multi-purpose support vessels, which were exported to clients in Mexico and Bahamas. With its increased capacity, today MDL is once again poised to tap the export market for marine platforms and heavy engineering products, as well as offering a wide range of services. Over the years, the shipyard has created facilities to take on any kind of shipbuilding project. We are equipped with state-of-the-art infrastructure and processes, which include a world-class design facility with a futuristic virtual reality center and sophisticated 3D software. To keep up with changing times, Mazagon Dock has modernized its facilities to undertake modular construction by investing in a 300-ton Goliath crane, module shop with a retractable roof, a second wet basin and a submarine assembly workshop for a second line of submarines. We are also in the process of reviving our ship repair operations and are open to developing a greenfield shipyard at Nahava, Navi Mumbai. With a ship lift, wet basin, workshops, stores and buildings, and a ship repair facility spread over an area of 40 acres. Our workforce is highly talented, trained and motivated, and at MDL, service to the nation is a commitment which is followed with passion. MDL got listed on 12th October 2020 on BSE and NSE and disinvested about 15% of its shareholding. The investors' confidence in MDL led to the issue being oversubscribed by 157.4 times, highest amongst any PSU till that date. We are the warship and submarine builders of India. We contribute to national security. We participate in nation building. We make in India.
So this would have given you a little idea about what we are. These are our products. Basically, we are having two divisions operating under MDL. One is over the surface, over the water, and one is underwater. So over the surface is nothing but warships, under the water is submarines. As brought out in the AV, you could see we are the only shipbuilders who have experience in constructing the conventional types of submarine as of now in India. With regards to our capacity, as brought out here also, earlier the capacity was 6 submarines, now it is 11 submarines because we have established another line. This is all to ensure the earliest deliveries considering the benchmarks of the world. We, as a MDL, support Navy not only by constructing and delivering the submarines or warships, but we are also undertaking the medium refits. Refits are nothing but which is equivalent to your servicing of the vehicle. So it is basically a midlife refit of the submarines and ships, where we dismantle everything and we install and ensure the complete trials successfully done on the platforms. So it gives a rebirth to the existing ships and submarines. So that's in total what we are. Apart from that, we were into the business of offshore with ONGC, which was discontinued to support the requirement of Indian Navy. But after a period of time, when we are improvised our capacities with available spare, now we are also re-entering into this similar business. Since we have the capability competencies, so it has been decided, referring the directives of the Government of India also, that we are venturing into the business of offshore. Now, these three product lines, when we keep in mind, which are more relevant to today's topic. As a submarine, if I would say, because I am from the submarine background, although I am a technical person, but a complete experience or involvement is in the commercial and contracts. However, as I could see during my tenure, a lot of specialty materials also we do procure. Now, which kind of it could be? It may not be necessarily all polymers or polymer based. There are different materials that those are required, right from the steel. Steel itself is a different in submarines, which is not indigenous. So there's a scope starts right from the hull. So since it is a polymer based, but I'm just diverting from the topic probably. In steels also, we have a variety of materials which are not manufactured in India as of now. When you look at the SAIL or Midhani or whoever private players are. There are some other materials, equivalent materials are being developed by DRDO also, which are about to be used now in the prototypes forms. So steel is one part. Apart from that, there are another soft materials, insulation materials. These all are specialty materials that we do use in the system to design the system and ensure the development subsequently. So to just go through a presentation wherein I could show you which type of material, there are 7 to 8 categories I have made just to give a gist of it to you. Probably I may not be able to give you complete details about this material per se, but during subsequent interaction with us, you can come forward and ask us about the further details in which you are basically expertise in. So we can organize technical discussions with my technical experts. If you are expressing the interest to develop further, we can progress the things further. Of course, about MDL, you have seen the AV. This would have been more clear because we are basically into building the destroyers and conventional submarines for Indian Navy. This is our portfolio. We have built as of now 27 warships and 7 submarines. Of course, paramilitary ships, commercial ships, exports, and even offshore rigs, which was discontinued earlier. Now we have regained and reviving that business as well. This is a major category in any shipbuilding area. The materials are basically divided into 4 categories: structural and hull, engineering equipment based, and electricals and weaponaries, the combat. I think Captain Vaidya has also mentioned here, apart from weapon, there is a lot of scope for polymers or otherwise a separate materials, kind of a thing, or specialty materials that we call it as. In this case, the hull engineering is basically fabrication, structural, it's a completely steel base. Engineering, these are equipment based, electrical, of course, specialty electrical equipments and weaponaries. This list I am exhibiting specially what exactly we need in specialty and what is being used in shipbuilding and submarine. Of course, asbestos-free fibers, then NBR, because this is one of the critical item. I just would like to make a mention here, in submarines specifically, as of now, we are importing 99.5% of material, including steel, equipment, specialty materials, whatever. So, we have a full scope to indigenize this material. Under the directives of MOD, DDP, we are also extending our support to industries who are willing to develop in terms of finance, like if you have a development interest, if you approached us, we also extend a percentage of investment that you are looking forward to do. Of course, you will have to come forward and invest partially, we will invest partially, and let's take a project ahead towards success. Because majority of the MSMEs are not reluctant, or rather I would say due to financial constraints, they don't come forward and do the development. That is what is the prima facie an output that we could see when we released the tenders for the specialty materials, including other equipments also. So following the DAP 2020 Defense Acquisition Policy, we have decided to invest the amount whichever is required to indigenize at least 60% of the total chunk of submarine. Let's say, assume in terms of a business potential, all our businessmen and entrepreneurs, one submarine costs us in today's scenario, if you take a reference of Israel, who has recently concluded a contract with for German submarines, it was 8,000 crores in Indian rupees for a submarine. So that is an advanced submarine that they are buying. Even we are also buying, likely to buy the new advanced submarines from any of the OEM. That is likely to be costing within the range of 8 to 10,000 crore. We have, as per Maritime Capability Perspective Plan of the Government of India, we were supposed to have 30 submarines in our fleet by 2030, which was released in 1999, out of which 12 submarines are already being inducted, or are being inducted, rather I said. There is a scope of 18 submarines. So there is a complete, if you turn out to be, out of which there are around 12 submarines which are diesel electric propulsion, I mean conventional. So there is a scope of around 1 lakh crore business potential in upcoming 7 to 8 years, of which we are looking forward to do indigenization of 60%. That would straight away take you to the 60,000 crores indigenization in upcoming 6 to 7 years. So this includes equipment, specialty materials and everything. So with that intent, as per directions of the government and MOD, MDL has undertaken the indigenization drive, for which around 128 tenders are already live, which includes this kind of a materials as well. It is not specifically for specialty of materials, but it includes even equipment level, pump, motors, or even GRPs. All those we are looking forward to get it indigenized. So these items are available on Shrijan portal. If you can go through the Shrijan portal, that portal is live and used by all MOD's DPSUs, wherein whatever we wanted to develop, we put the data on Shrijan portal. Probably most of you may be knowing about that. So follow the Shrijan portal as well as even GEM tenders, because following the policy of DAP, we have released 128 tenders almost on a make one and make two basis. In make two basis, of course, the design and development completely by the vendor or industrial partner. And in make one, we are also likely to get, put in our money. That means investment is by the MDL. So there are two type of categories of these tenders are available on the GEM and even on the Shrijan portal. Through Shrijan also you can go through the details about the requirement of MDL. So prima facie, as I said, there are 6 to 7 categories which are nothing but an asbestos-free fibers, NBR, polychloropin rubber. These are the basic properties which I have. Probably I'll share this slide with MCCI so that it can reach out to you. Even silicon, then we have different kinds of rubber, GRP, acrylic glass. There are miscellaneous plastic items also which are required in huge quantity, even Teflon. So these are primarily 8 to 9 items are required for submarine to know about the value of it, it could go up to 20 to 30 crores total per submarine for this kind of items. Based on the requirement, various requirements are there. But if you say the total quantity that we are looking forward per submarine can go in terms of monetary limit, it could go up to 25 to 30 crores. So likewise, 6 submarines, if you can say, if you consider as a requirement of, it could reach out to 100 crores altogether. There are projects upcoming. Maybe we are likely to conclude few projects by 2025 and 2026 with the Government of India for Indian Navy. Considering the requirement therein, we need to develop these items before that. So we have the timelines for development, maybe 18 to 24 months. The full support in terms of finance, as I said, is extended. We would like to have your participation in tenders wherever the technical help is required. See, generally this composition-wise or your mixture-wise, or maybe we can say the chemistry-wise, we can help you out with the material. Because existing material, specialty class of material is already procured from our collaborators who are abroad. They are German, they are French, European. So we can't give you any detailed specification. That is the limitation which we have because of IP infringement aspect. So we would like to do something innovatively. So considering the performance parameters, how can we innovatively design our chemical compositions, or we can formulation is made in an innovative manner so that it won't lead to any IP infringement with the overseas parties with whom we are presently working with. So since we are, they are losing their business due to indigenization, probably they are not interested to share anything. They are not sharing even IP rights with us. So that is a major challenge which we are facing during indigenization. To come up with, we need an innovative support from industry partners to develop it innovatively so that ultimate performance parameters remain same. And the IP can be also filed subsequently, which will be owned jointly with us. So that subsequent requirements, not only limited to MDL, but by Indian Navy and other yards of the Navy. There are 4 types. Eastern Naval Command is there. Western Naval Command, who is also buying separately. There is an indigenization cell of Indian Navy, which operates within itself, Directorate of Indigenization, who sits in Chanakya Bhavan, Delhi. They are also working on this kind of aspects. So once you develop the things with us, probably your business will grow in a 4-fold for the same requirement in terms of spares. You can see here, for example, O-rings and seals. These are really consumables for which we are struggling, because every now and then if the pump fails, we have to replace the seal. In that case, we had to go to, or we have to be dependent on the OEMs to get the spares as well. So if we could manage to get this developed in-house, it will reduce the dependency as envisaged during framing the policy of indigenization. So we as a MDL, we are also extending our support in terms, not only in terms of a technical, but financial as well. And we expect the industry to come forward and give us or express their interest to participate in such tenders, which will lead to a real national capability development program that is envisaged by MDL now. So I just don't want to go much technically on this, because this forum would take a long time if we get into technicalities of it. But I request you to get in touch with us on this email IDs with your requirements. We will direct you to our technical experts as well, because similar requirements, if you would, there may be a case, the requirements are already exist, or that might have already been developed by you somewhere, and we are unaware of it. Probably that could be scaled up, scaled down, technology is already existing. So it would be easier for us to develop shortly and use it in the system itself. So that's all from my side. If you have any questions with regards to establish a business with MDL, probably I'll give you 3 to 4 minutes, I expect, if they have. Joint session, that's fine. So we can, as planned by them, you can keep your questions ready so that we will be able to answer you on the front of how to reach us and how to get it registered with us, engaged with us for the future business. Thank you. Thank you.
Thank you, Mr. Jende. I would now like to request Mr. Atul Kamble from Bharat Forge for his talk on the outsourcing requirements of Bharat Forge. Also, probably he'll focus on some quality norms which companies have to follow, and a little about vendor registration part. So after he finishes the talk, we'll have a small question answer session. So I'm sure there'll be a lot of questions. Then we'll have a joint question answer session. You need to put your laptop.
Good evening, everyone. Myself, Atul Kamble. I'm looking domestic procurement as well as heading the domestic procurement in the Bharat Forge, as well as I'm looking after some forging related procurement in Bharat Forge. So we'll just start with the presentation. So all of you must have known Bharat Forge as a big forging organization, and many of the automobile component manufacturing which is happen in Bharat Forge. So from last couple of years, Bharat Forge are diversify themselves in other segments as well, like aerospace, defense, automobile, oil and gas, marine, railways, wind energy, mining, construction, and some thermal power. So in automobile, we are manufacturing most of the crankshafts, connecting rods, chassis parts, transmissions, then some gears, like that, components. And in e-mobility, we have the tie-up with torque motors for e-bike, that is Kratos, that the model is Kratos, right? In aerospace, we are making some components, some blades part. In railways, we are supplying turbochargers, then some of the bogie parts. So these are the parts we are diversified in other sections also. These are some group companies of Kalyani Group, Kalyani Steel and Kalyani Carpenter, which cater the most of the steel requirement for the forging plant only. So 90% of the steel requirement fulfilled from the Kalyani Group companies only. Secondly, some of the defense joint ventures like Kalyani Strategies, VFL Albeit Advance, Analogic Control is our group company, then Kalyani Rafale. These are also joint ventures we done with for the defense projects. And some of the foreign group automobile companies situated in Germany, France, and USA. So why defense? So first of all, Bharat Forge is in metallurgy company and good know-how in the metallurgy area. Secondly, we have the innovation center in Keshwanagar, where we have the facility of heat treatment, then some material testing, battery-operated battery testing facilities, then PCB manufacturing. Like that, facility is available at our in-house R&D center. These are some defense product which we have manufactured, like artillery gun. Artillery gun attacks, you must have known this gun we have developed long back. Now we are getting some good orders from the MOD for this attack artillery gun. Then in protector vehicle, we developed Kalyani M4, that is armor vehicle, which is joint venture with Paramount Group, South Africa. So more than 50 plus vehicles already delivered to MOD, and some of the good orders which we are executing. And some other sections like air defense, ammunition, we got the bomb shells orders for good quantity. So these are some in-house facilities, like we have recoil mechanism that facilities having in-house in Bharat Forge Mundwa facility. Then barrel, breech, and muzzle, that product also making in-house. For some servo drives and other parts, we have joint venture with some of the strategic partners we are developing. And all the integration is done in-house. These are some pictorial views or some products which we are looking for vendors, like rubber parts, pipes, rings, some other mechanical parts. These are some assemblies where we are looking for some vendors who can do these kind of assemblies. We can give all the technicals and the drawings to the vendors, but they should develop such kind of parts for the BFL. These are some R&D projects. We are also in like e-cars vehicles, DMDD, then some other lightweight bulletproof vehicles and guns. As I told, this attack gun, we have done the record that longest distance is around 48.07 kilometers. These are our criteria for supplier selection. Our quality team will visit at your works and assess for the parameters. They will assess on this basis of safety, material logistic moments, management in your company, what the quality systems you are following, then what advanced planning you are doing at your end, then some material controls, then testing facility, what you are having, that calibration and testing facilities. These are the parameters. On that basis, the vendors will be assessed, and some scores will be given for the vendors. Based on that score, it will be onboarded in your system. And these are some registration documents which need to be followed. So we will be able to send you the online registration link to you. So these are the basic documents need to be furnished, like PAN card, GST certifications, then bank details, SSI and ShopAx, partnership deeds in case of partnership firm. And some of the documents need to be signed with the BFL, like terms and conditions, supplier code of conducts, and some NDAs. So these are some categories for which we are looking for the vendors. That categories in electrical, then automobile components, the fabrication and machining components. These are the details. In machining, we are looking for the facility who having good setup in PMC, CNC, and having some good knowledge in this field. We are expecting some vendors in that category. Then fabrication, we are looking for some good facility in bending, welding, and laser cutting area. Surface treatment, we are looking for some phosphating and chrome plating type of treatments in our facility available vendors. Please do contact us if you have these facilities. There's fasteners, some of the special grade springs, some of the raw materials. In Kalyani M4, we are using some ballastic property steel. That kind of steel, we are looking vendors for that. Then hydraulic and pneumatic system who can design, develop, and integrate for us. These are some raw materials, a special kind of raw materials we are looking for. The grades are mentioned here. Then some of the electricals like harness, some mill grades, motors, connectors, controllers, and AC/DC converters. For this, we are looking for some vendors. some electronics requirement from our side. Mr. Nikesh will just explain how this requirement.
Good evening all. Myself Nikesh. Actually, we are facing some issues with finding some better and capable suppliers who will be fulfilling our requirement in terms of some electronics and manufacturing items, controllers, control units, and cable harnesses, so on. So we are looking for some suppliers who will be manufacturing these end-to-end solution for us for defense sector. As if now we have internal capability, but it is expanding now, and we wanted to outsource most of the item from local region, and wanted to provide opportunity to work hand in hand with local suppliers also. In electronics systems, we have requirement in armored vehicle as well as artillery guns. So basically the control units and cable harnesses and some sensors, active passive components, we are looking capable suppliers in this requirement also. If there are any capable suppliers in this program, they can reach to us, and we will be very happy to start business in this direction. Thank you.
So we can have a quick question and answer round. I would like to request Mr. Jende to come on the stage, please. So if anybody has any questions, you can just raise your hand. My colleague will help you out with the mic. So before we take questions from the audience, I have a very basic question, which probably both of you can answer. How to get associated with Mazgadox and with Bharat Forge? Is there a website where we can go to, or is there a form which you have to fill in? Just briefly.
With regards to the registration, in order to get associated, the first step is, of course, registration with Mazgadoc. Nonetheless, if you are not registered, doesn't matter. Following the government policies, we are releasing the tenders wherein open participation is accepted. So you can visit our website, mazdoc.com, where under tenders, you can find the tenders which are already released. It may happen that the category in which you are working, or your product that you are manufacturing probably is a requirement, and the tender may be live for that. So, and I'm not asking you to keep revisiting on a day-to-day basis, but at least in a once in a week, you should visit our website for the tenders which are being released. For every tenders, there is a response time of almost 3 to 4 weeks. So once in a week also you will visit, you will come to know the existing requirements of Mazgadoc, for which the open participation is accepted. Why the registration is required then? That's the second question. Because in case of open participation, every tenders, as you know, have a tender fee, EMDs and all, which includes the finances. But for MSME, under the micro and small scale industries, you need not to submit any EMDs. That's the exemption available to you, despite you are not registered with MDL. It's okay for us. If then again the question comes, why should we get registered? The registration is required only for one thing, that, as I said, once in a week you need to visit for your product portfolio that are being tendered out. That you can skip if you are registered with us. We will invite you, because your name in our empaneled list will force our purchase executive or commercial dealing officers to reach to you. So whenever the tenders which are important, for which you are registered with us, our executives will reach out to you and request your participation for those tenders. So in that case, even if you don't see our websites, that's okay. So that is the point where your registration is important. Now, how to do that? Registration can be undertaken online through our websites. You have to register through our website only, wherein you will fill all the forms, take the complete print of all the documents after submitting it online, make a hard file, and please forward it to our supplier registration and relations cell, which is headed by our general manager, materials. So if you that all instructions are available on the website. Despite that, I'm just informing you, once you send that file, it will be routed through the user department. So it could be submarine or shipbuilding, based on your profile and products, those you are aspiring to get registered with us for. Based on that, after seeking a recommendation from the user, your registration will be done. The general timeline, it will take from 4 to 6 weeks for the registration after you submit it online. If there is an undue delay, you are requested to reach out to us. We will facilitate your registration. So, thank you.
Thank you. Mr. Kamble?
Yeah. Hello. Yeah, in Bharat Poj, any vendor can register, depend on their capabilities. If the vendor is for standard source, like for some of the parts, authorized dealer or some OEM manufacturer, they can register vendor registration through our online registration portal. We will send a link to them. They have to fill all the details, like I mentioned, some of the documents, mandatory documents. They have to submit there. We will assess that. Then based on the user approval, user recommendation form and all that internal process, we can register that vendors. These usually take 1 to 2 weeks to register vendor in our system. For the manufacturing facility, for that kind of vendors, we have to make the assessment first. Our quality team will visit your works, do all kind of assessment. If you pass on that assessment, then we can onboard that vendor in our system. This is some basic procedure we have to follow for vendorization.
Okay, thank you. So basically we have the contact details of all the people who have registered for this event. So is it possible to share some details afterwards so that we can pass it on to the people who are here? Thanks. Any questions from the audience? Just please mention your name and ask your question.
Good evening, Aran Thawani, Renata Precision. My question is to Mr. Kamble. You mentioned the EMS box build. So are you looking for a complete assembly solution or manufacture that in-house too?
Actually, we float all the requirements which we have for our vehicles and the artillery guns. On that basis, you have to propose 2 or 3, you have to provide 2 or 3 proposals to us, on which we will start technical discussions with our internal technical teams and with you. After the finalization of these all technical requirements, if it is meeting the final requirement, then we can give you clearance to start design and development of this particular product.
Thank you.
Any other questions? Okay, so I think we'll pass on your contact details to the audience. Yeah.
Of course, you may not have any questions, but since we are here to seek your participation in our programs, I would like to add one more thing to what I said. Generally, registration is one part of it, but the qualification is other. Because in every government tenders that we release, we of course look forward for the qualified vendors. So it could be a specific area where you might have executed the similar orders previously. Likewise, you may find qualification criteria in the tenders. That is also equally important apart from the registration. However, following the guidelines, the startups are also encouraged So even if you don't have experience, you have a recently started new company which is which is in the development of innovative products, not only in the specialty materials or polymers, but even apart from that, and it is registered under DIPP. If you have a DIPP certificates, all those qualifications are exempted. So the registration is one part of it, but even startups and innovative products which you have are also can be considered under the qualification, subject to having DIPP certifications by the government for the startups. So just take a note of that, apart from the registration.
Right, sir. So incidentally, we have been having some interactions with MDL, and we already had one session on 23rd of March, I think. Just a month back, and now we are planning to have a visit to MDL just for equipment familiarization. So we will keep you updated about this development as and when it happens. So I would like to request my colleague Sunil to just come and do the honors, please. We'll be handing over a small memento to all our speakers. So, Mr. Jende. Mr. Kamble. And Mr. Nikesh. And we'll have a group photo. We have come towards the end of this program, so I am requesting my colleague Sunil to give a formal vote of thanks. After the vote of thanks, we have the tea ready, so we'll have a tea break and then we'll disperse. Thank you.
So it's finally end of the our entire sessions. So first of all, thank you MCCI for giving all this facility and sharing this session with us, Indian Plastic Institute. Thank you the academia, ICER and MIT for participation in the event, Dr. Bhagwat and UDCT and MIT. So MIT has sent 2 staff members, Dr. Mallari Kulkarni and Dr. Anaga, and 10 students who had supported this event. So first of all, I would like to thank all of them. Then, of course, Dr. Radhakrishnan was there for us to guide for entire event, and various alumni from all these institutes. Next is, I don't want to say all the names, but entire defense sector has supported this entire event. I would like to express my sincere thanks to Chairman Abhay Upadhyay for coming all the way from Ahmedabad, and Mr. Vijay Goyal coming from IPF coming from Indore, and various IPIs, these dignitaries coming from the Mumbai office. So I would like to thank my colleagues, Imtiaz also, and Narendra. Thanks to Ranjit Jadhav coming from all the way from Nasik for this event. Thanks all of you coming from various corners of the India for this wonderful session, and you made this day. And last but not least, all the sponsors and the sponsor of the stalls, the speakers, and various backgrounds supporting staff to make this particular event successful, and we hope we'll meet soon for the next event. Thank you very much.
Yeah. So let us join for a tea and then we can disperse. Thank you very much.